Good morning, everybody. Very welcome at ELAT. At our event, I would like to ask you to seat yourself. In 2 minutes, it's 10 o'clock and the live stream starts. So also the conference will start. We'll start in 2 minutes. Lots of people are at the registration desk. Welcome everybody at the ELAT conference on bidirectional charging. My name is Baerte Brey and I work at ELAT for over 10 years on bidirectional charging and embedding the standards and protocols my colleagues, Lonneke, develops to embed them in rules and regulation. Years ago, we had a small test in the Netherlands, in Amsterdam, in Utrecht, and on a lot of conferences, bidirectional charging was just a topic. You saw some slides on a vision, PowerPoints, but nowadays, well, our test in Utrecht is knitting together with tests in Göteborg, in France, in Germany. And we get much more questions on not only what is the vision, what is the business model behind it, but what are the techniques? What do our entrepreneurs have to develop, innovate, or embed in their procedures? So there are a lot of questions, and we don't have all the answers, but we want to bring the community on bidirectional charging a bit together to discuss on these topics, to make a mutual roadmap on standardization, development, collaboration. What do we have to do? Not only here in the Netherlands, but also in Asia. And of course, we'll, in a few minutes, we'll kick off with the California Energy Commission to get a bit of feeling what's happening in America. But first, I would like to introduce our director, Onoph Caron, to tell something about where are we and what are we doing here.
Thank you, Baerte, and welcome to you all. Also welcome the people who are looking at the stream online. Welcome at ELAT, our premises since June last year. Let's see how I do this. Okay, yes, before we start, some safety requirements. Of course, we hope nothing goes wrong, but if this would happen, there's an emergency exit to the left for you, and at the back where you entered, there's a second one, should be enough. If there is a big crisis, then there's a meeting point at the end of the parking lot. As you have seen, there is equipment here and there, inside and outside. Please be aware and take notice that it's high technical equipment, and be careful with that. Of course, no smoking, that's a thing to be mentioned. You've entered the building over there. We have several security zones, so you will not be able to enter all the areas, but going to the toilets is over there, and coffee and drinks over here, so it should be okay. One other thing, this is it is not a congress venue, it is a testing laboratory, so the acoustics are not extremely well, but on the other hand, if you speak loud and clear, also for the speakers, then you should be fine to hear everything. And we will have an extra mic if there are questions in the room that will help you to be hearable. So this is what I wanted to start with. Next slide, please. Kan ik dat zelf doen? Ja. Right. So, for those who are not familiar with ELAD, ELAD is a non-profit organization founded by the grid companies in 2009. And the simple task we were given is investigate everything that has some way or the other an impact on the grid. Where are you now? You are at the ELAD facilities on an industry park, the most sustainable industry park in Holland. In the green square you can see the building which we are in, which we occupy a small part in. This is under development, as you have seen outside. Within a year, 1.5 year, this will be a venue with some 40 innovative organizations, all working on sustainability, hydrogen, EV, etc., etc. So it will be a very interesting ecosystem. And one of our neighbors will be the University of Arnhem. And so there will be a very nice interchange between students and what we are doing here. We were very proud that in June last year our king opened this venue. And we had a very interesting discussion here, and as of that moment on, things like today happened almost every week. It's been very busy since then. Very nice. So, what do we do at ELAD? Just briefly, because it's not part of the V2G, but just to know what we are doing. A lot of stuff. So we do data analytics, we do projections for the future for the grid companies. Net impact analysis, I'll mention just a few. Of course, power quality measurements, we have equipment for that. Up there you see a small, like a house. We are working on home energy management systems. We are heavily involved in cybersecurity, a topic which is also very interesting. And of course, smart charging and V2G. But then I'll give the mic to Baerte again, because then we'll start the official program. Very welcome today and for some the rest of the week, and I hope you will have an enjoyable time.
Thank you very much. There was one small error in the presentation by Onoph. The king didn't visit here for the opening, to open the lab. It was a field visit, because what it was really about was a visit by the king and his wife to California in September, so they could advocate what we're doing here towards the Californian government. And this resulted in a signing ceremony with the California Energy Commission on collaboration on both sides of the ocean, America and Europe, Dutch collaboration on standardization and setting next steps on integrating electric mobility into the energy system. And to express what's happening in America, I would like to give the floor to Ben Weder from the California Energy Commission for a presentation on his behalf and his organization. You got your mic. He traveled a long way, so applause is welcome.
Thank you, Baerte, and thanks to everyone here, our hosts at ELAD, for the opportunity to come share some of our lessons and priorities in California, working to advance vehicle-to-grid technologies while we simultaneously decarbonize transportation systems and electricity systems. We have a lot of hope and optimism about the role vehicle-to-grid can play to help make this transition more efficient, faster, and lower cost for all of the ratepayers and taxpayers in California. My name is Ben Wender. I'm a special advisor to Commissioner Patty Monahan of the California Energy Commission. I'm going to spend a couple of minutes talking about the policy context, regulations in California, and then share 3 key priorities that we're working on to help bring us to a future of widespread commercial V2G. California has established some of the most ambitious policies and regulations for transitioning our transportation sector to zero emissions. I won't read all of these, but some highlights. By 2035, 100% of light-duty passenger vehicle sales in California must be zero emission. This will be followed in 2045 by 100% of the operations of medium and heavy-duty vehicles. So that's a little more than 20 years to transition essentially all of the vehicles and transportation activities in the state to zero emission, many battery electric vehicles coming. At the same time, we are transitioning our electricity system to be zero carbon and increasingly relying on variable renewable powers sources. Today, more than 1/3 of the electricity sold in California is produced by renewable resources, and this will increase to 100% by 2045 under state law. As I'm sure many folks in this room have thought about, when you simultaneously decarb transportation and electricity systems, decisions about when electric vehicles charge and in the future discharge makes a big difference for cost, how quickly we can make the transition, and ultimately the environmental savings and benefits of the transition. Clearly, we want to charge these vehicles at times of high renewable production, low greenhouse gas emissions, low wholesale electricity costs. And we want to not charge, and more importantly, to discharge vehicles during times of high electricity production or high electricity costs, high emissions, and production from fossil resources. I say in the future because I have to acknowledge today bidirectional charging in California happens on a relatively limited pilot scale, maybe a megawatts scale of bidirectional charging. But collectively, we're working in 3 broad areas to make bidirectional charging grow from the pilot scale to widespread commercial deployment. The first is encouraging commercialization and deployment of more bidirectional vehicles and chargers that are available to customers and drivers, making bidirectional chargers and equipment easier to install and interconnect to our electricity distribution systems, and creating rates and programs that provide an economic incentive for drivers to charge and discharge in ways that are good for the electricity system. I'll talk about each of these and give some highlights of the activities that we've been working on. In the first category of encouraging development and commercialization of more bidirectional vehicles and chargers, California uses its purchasing and incentive programs to help reduce the cost and encourage more products that are bidirectional capable. And importantly, and a theme that we'll hear a lot about over the next few days, that this equipment uses open consensus standards that facilitate interoperability between different vehicles, different chargers, and really provide the foundation for scaling this industry. One of the first programs California worked on that advanced and used its incentives to encourage more development of bidirectional vehicles was called the School Bus Replacement Program. This provided funding for school districts in low-income communities to replace diesel-polluting school buses with electric alternatives. And the program had a lot of foresight in requiring the capability that buses purchased through it be able to discharge electricity, DC, through the CCS standard. As of today, there are about 195 of these school buses driving and operating in California, and another 35 are on their way. However, the vast majority of vehicles in California are light-duty passenger vehicles, about 40 million of them in the stock. And so clearly, more bidirectional offerings are critical in the light-duty sector, and we're really just beginning to see these vehicles roll out. The Ford F-150 Lightning was the first passenger vehicle warrantied and marketed as bidirectional capable in California. Last year we sold about 2,200 of them in the state, although not all of them have been installed and paired with bidirectional infrastructure. 2,000 out of about 2 million vehicles sold over the last year. This is less than 0.1% of the light-duty vehicle population, and so California and collectively all of us together have a lot of opportunity to provide and grow vehicle offerings in this segment, and I'm excited to hear from our colleagues at OEMs about their plans for rolling out more bidirectional capable vehicles. Now, in the second bucket of making bidirectional chargers and equipment easier to install and interconnect to our utility distribution systems, we've worked a lot at the Energy Commission with our colleagues at the Public Utilities Commission and throughout the state to gain familiarity and acceptance of bidirectional charging technologies, to establish pathways to allow them to connect to the grid, and to help reduce the costs of upgrades or installation at facilities to make it more accessible to customers. Over the past few years, we've formalized interconnection requirements for bidirectional chargers, DC-based bidirectional chargers that are applicable across all of the state's investor-owned utilities. And customers are beginning to apply and purchase equipment and apply to utilities to connect to the grid. One of the challenges we're seeing, and I'm showing a slide here from a colleague at Pacific Gas and Electric, one of the investor-owned utilities, is that beyond the high cost of buying the charger, that's in blue, the hardware costs for upgrading your home, adding panel capacity, doing the work can add substantial costs to the customer experience, sometimes 2 to 3 times the cost of the charger hardware itself. This can result in costs of $10,000 to $20,000 for a customer to install a bidirectional charger beyond just the purchase of the vehicle. And so the state is working and beginning to evaluate opportunities to help customers mitigate and defray these costs to allow not just bidirectional charging, but electrification of other end uses, heat pumps, which will all have to happen over these next 20 years. The last area I want to touch on is creating rates and programs that provide economic incentive signals for customers to charge in ways that are good for the grid and discharge in ways that are good for the grid. One of the most recent programs we've developed in the state of California is the Emergency Load Reduction Pilot Program, which compensates customers up to $2 per kilowatt hour of energy discharge during critical peak times. Last summer, California had the highest electricity demand ever in its history at over 50,000 megawatts, triggering demand response events that those same school buses that were funded initially by the Energy Commission participated in, exporting about 750 kilowatt hours to the grid during these times of peak demand. This provided economic compensation to the school district and the aggregator providing the service, and contributes to the reliability of California's electricity system. And so this is another example of the types of rates and programs that we're developing to try and roll out, and California is exploring opportunities to expand this program beyond just the state's investor-owned utilities, but to all of the energy providers in the state. So those are 3 key priorities California and collectively all of us can be working on to help bring vehicle-to-grid technologies from beyond the pilot scale to widespread commercial deployment, and to create this future that truly integrates the transportation system with energy systems instead of just adds electric vehicles to the electricity system. And so with that, I'm Very excited to be here today to learn from all of you what you're working on here in the Netherlands and the European Union broadly, what lessons we can bring back and collectively work together to make this future a reality. With that, thank you very much for the opportunity again, Baerte.
Yeah. Thank you very much for your long travel here and your presentation. Can imagine there are questions. Please save them a few minutes because after the next two presentations, we'll do a little bit of panel discussion with room for questions and answers. Lonneke, may I ask you? Lonneke is our director test lab and a fellow grid operator here in the Netherlands. And that's what your presentation is about.
Yeah, thank you. Thank you, Baerte. So while Martijn puts up my slides, welcome everybody. As Baerte introduced me, I am working for ELAT. I do many things for ELAT, amongst which is having the managing this whole test lab. I'm the director of the ELAT test lab. But additionally, I also work for the Open Charge Alliance. The Open Charge Alliance, some of you may know this organization. It is a non-profit industry foundation founded back in 2014. And the purpose of the Open Charge Alliance is to govern the development of a protocol called OCPP. OCPP stands for Open Charge Point Protocol, and that is the information exchange protocol in the charging infrastructure. So it communicates from the charging station back to the back office system. So we are an open source standard, so anybody can download OCPP and use OCPP, that's all fine. But you can also choose to help with the development of the protocol itself and join a group of currently more than 300 companies who are working on continuously developing the protocol to match the needs of the industry. And that's exactly what we've been doing for the past over a decade, but on the particular topic of vehicle to grid, I think we've been working for around 6 years already to figure out what information exchange is needed. And as Ben so eloquently phrased, what's really needed is for everybody to work together to make bidirectional charging easier to install and interconnect, and we do that by developing a standard for it. So I mentioned that we already started working on bidirectional for a long period of time, and our main focus in the beginning was on the information exchange between the vehicle and the charging infrastructure. And of course we all started with CHAdeMO, the protocol that enables bidirectional power flow for a long time now. And once we got a feel for the information exchange needed, we had a first set of V2X messages for OCPP. And of course, at a certain point in time, I think 2 years ago, 2.5 years ago, a draft for another standard became available, the ISO 15118-20. And that's when we looked at the changes needed to OCPP to, in addition to supporting CHAdeMO, also support the bidirectional power flow features in ISO 15118-20. So what you can see from the orange dotted line is that our main focus was the vehicle, the charging infrastructure itself. But you of course see in this picture there's a very important stakeholder, which is the utility. And once you start feeding power back into the grid, of course, the grid operators or the utility companies have a huge, tremendous interest because of course it's their job to keep the electricity grid safe, secure and stable. And we sort of learned that utilities, when vehicles start pushing power back into the grid, EVs become, in their view, power generating modules. So it's no longer a car, it's no longer a mode of transportation, but it's going to be a power generating modules. And of course, utilities have the responsibility to make sure that everything remains stable. There are developments in views and ideas that utility companies will directly control the bidirectional power flow by controlling the inverters. And then of course a possible way. But when it comes to controlling these power generating modules through the charging infrastructure, then of course OCPP comes into play, and that's what I'd like to focus on for now. The reason why utilities are such an important stakeholder for V2G is because it's written in the law. And when I mean law, I don't mean a legal law, like the law from the California Energy Commission or grid code law, but actually it's embedded in the laws of physics. So here you see a picture of two gentlemen. You have to look really closely because they're two different gentlemen. They look very similar. This is a picture from the 19th century. Not a lot of diversity back then. I know ladies in checkered dresses on the stage. These are two different physicists. To the left, if you're an electrical engineer like me, you may recognize them. So to the left, you see a gentleman called Kirchhoff, which was a German physicist. And to the right, you see a gentleman which is called Mr. Maxwell, and he was a Scottish physicist. And they sort of laid the foundations under the physics that have, in the end, resulted to our electricity grids. And of course, you can ignore the law of the California Energy Commission if you like, but you can never ignore the law of physics. So that's why listening to utilities, when you want to push power back into the grid, you really have to do that because, otherwise the system will just not function. So what we did as a consequence, we said, we think we sort of have the information exchange from the vehicle sorted. What are the requirements that utility companies have? What do they need? And we were informed that, well, this is in grid codes, and there are many different utilities, so there are many different grid codes. So there's a lot of different requirements that you need to consider. And I looked it up last night, and indeed, across the world, there are more than 900 transport system operators and more than 7,000 distribution system operators. So 8,000 companies having these grid codes and regulations. So we thought, there are a lot of grid codes possibly out there, but they can't be all different, right? So that's why we explored a little bit further. What are these grid codes, and can we work with those? So luckily, already a lot of very good standardization work has been done. Really clear and really complete standards are already out there. So we've looked at those, and I hope you can read it. So the main standards we looked at are the IEEE 1547 and the EN 50549. So these standards are available and ready for everybody to read and interpret and to see what actually are the requirements from utility companies. They don't describe everything. On top of that, many countries also have their own grid codes. And just to get started, we focused on the grid codes from France, from Germany, from the Netherlands, to sort of get a first idea of what are these requirements and can we match them with OCPP. And additionally, we looked at, in addition to the requirements, there's also a communication coming from the utilities. So what are some standard protocols that utilities could use to communicate their requirements? And we looked at the IEC standards, 61850, and a very clear and very comprehensible standard called the IEEE 2030.5. So basically our next job was to translate, if these are the requirements, these are the information exchange protocols, what does that mean for OCPP? So looking through all those grid codes and all those standards, although they're all slightly different, they all have the same things in common, which are listed here on this slide. So when you are a power generating module, which is a bidirectional vehicle, there are 4 things you need to consider. So first of all, if you're feeding back power into the grid, you have to adjust your behavior according to the grid frequency and the grid voltage. You just have to listen, what is the grid frequency, what is the voltage, and depending on what happens there, you have to adjust your behavior. And this is exactly what I meant with these are just the laws of physics. You just have to abide by these requirements. The second thing that all these grid codes have in common, that utility require you to listen to a direct stop signal. So if something really goes wrong, please stop feeding back into the grid. It's also universal. The third is the requirement to continue your operation when there are grid hiccups. So the electricity grid, of course, is alive. Sometimes there are small disturbances and you shouldn't be put off. You shouldn't just drop feeding back into the grid if you see the first sign of trouble, because if you do that, then you get a cascade effect and you will only make things worse. And the last one, also really important, when usually the grid is up, but when the grid is down and you're feeding back into this grid, you have to detect that it's down. Of course, immediately stop feeding back into the grid. And once the grid comes back up again, you shouldn't just bluntly reconnect, but you should reconnect with care. So if you just adhere to these 4 principles, and those are universal across the whole globe, then you're good. So this was really encouraging for us because OCPP, as you may know, is used everywhere. It's used in Korea, in North America, in Europe, in India, in Japan, everywhere. So of course we want to accommodate all the grid codes everywhere, and it's good to learn that in the end they all are very similar. So the result where we are today, so we have 2 changes, new updates to OCPP. We've sort of split them in 2 publications. So the first is the adding the DER, Distributed Energy Resources, to OCPP, and adding ISO 15118 and V2X to OCPP. Not everything in ISO 15118-20 is about bidirectional, and not all bidirectional is about -20, because of course you also have CHAdeMO. So these 2 publications are now available, and a lot of companies are already implementing them, testing them, and giving us feedback on whether they are complete, concise, comprehensible, and in that way helping everybody to help develop bidirectional charging in a scalable and standardized way. The slide says here specifically, it seems that it should be okay. Of course, we never know. As Ben mentioned, a lot of it is still in the early stages. So we think it's okay, but of course we need many parties to implement it, try it out, scale it up, and then give feedback to make sure that we're good for, not for just for now, but also for the foreseeable future. What we learned in the end is that the OCPP part for bidirectional is not the hardest part. It's not really complicated, of course. What is the most complicated part is, of course, the development in the vehicle, development of the charging station itself. But at least this piece of the puzzle we think we have solved for the industry. The Open Charge Alliance, as I mentioned in the beginning, is an industry association, so everything we do is done by the industry. And to conclude my keynote, I would like to highlight all the companies that were invaluable for developing these OCPP messages. And you can see them here on the slide. I will name them one by one. So thanks to BMW, ChargePoint, Dekra, Driivz, Eaton, EDF, Elaat NL, of course, Greenergenic from Korea, Kostal, Stellantis, and Switch. Those were the companies who saw that working together on bidirectional will help everybody forward. And it is on the shoulders of these companies that everybody else can stand. So I'd like to ask you to give a warm applause for these companies for the great work that they've done.
Yeah, thank you very much, Lonneke, and thank you very much for all the work you've already done. But this is also an invitation for other companies to join because, well, as you've seen in California, in Europe, in Asia, vehicle-to-grid is the future. And the vision of Elaat is it's better to work on this together, to set a global standard to achieve climate goals. Nice to have the grid vision. We had Ben with the California vision, with the governmental vision. But of course, there's a big role in implementation in local societies. And that's our next speaker, Matthijs from the municipality of Utrecht. What do we have to do to make this operational?
Yep.
Floor is yours.
Thank you. One moment. I will start my introduction. Thank you for the possibility to give a presentation here. I'm Matthijs Kok. I work for the City of Utrecht, the municipality, and I'm responsible for developing the charging infrastructure in Utrecht. We've been working on developing a charging network for charging electric cars in our city since, I think, already 15 years, now 12 years approximately. And we've been working on a bidirectional system since approximately 2015. And I'm going to explain a little bit more on this when my presentation starts. I will explain why it's important to also invest and cooperate in the development of bidirectional charging in our city from a city's perspective. Oh, there's some issues with the presentation. So what have we been doing over the last 12 years on developing charging infrastructure? What we do in Utrecht, we as a city, we want to if people want to charge their car, we want them to be able to charge their car, and that's why we install public chargers on the streets. That's ordinary chargers like you see them everywhere here. And since 2015, we've started developing, yes, there it is, a system of bidirectional chargers. So this is the first one of the bidirectional chargers we have installed in Utrecht. It's just an ordinary charger, like we have currently 1,500 installed in Utrecht with a total of 3,000 charge points for charging all electric cars that are coming to our city. We have a prognosis on how many cars we expect there to come to Utrecht, and we will have almost half of the private cars in Utrecht electric in 2030. And on top of that, there will also be an important development of vans and trucks going electric, because we implement a zero-emission zone for logistic delivery in the inner city in 2025. So that will also steep up heavily the next years. And we have an ambition to implement a zero-emission zone for passenger cars in 2030. And that's how we come up to these figures of electric cars that needs charging. We developed a plan to make this transition to electric mobility, and we see 3 parallel developments in the energy transition that we have to cope with as a city. The first is electric mobility coming in. We need approximately 6,000 AC chargers in 2030 on the streets to charge all electric cars. On top of that, about 30,000 private charge points at companies, in garages, at people's home. And additionally, about 500 DC chargers at shopping malls, sporting facilities, petrol station. And additionally, and that's especially a big challenge for us, is a lot of DC chargers for trucks and lorries and vans on in the I don't have a pointer, do I? No. Oh. Erik. Oh, I'm back again. All the blue chargers you see are DC chargers for trucks and vans, and they are really located in a really compact area, and that's especially from a grid perspective really challenging. Then there's another development. We have an ambition to have in 2025 25% of the rooftop covered with PV solar in Utrecht. We already met that figure last year. So actually that development is going faster than we expected when we set this goal in 2020. This is also needed to feed into the grid. That's really challenging for us. And there's a third development that is important. We are going away from heating houses with natural gas into other solutions. In the city, that will be mostly distribution grids. So then it's heat pipes bringing heat into the houses. But in some areas, depending on the type of housing, that also will be electric heating. And then also that brings an extra demand from the grid. Now, how does that work out in a typical neighborhood? We were there yesterday, Ben, in Lombok. That is our demonstration area since 2014, 15 for vehicle-to-grid technologies, but it's also an ordinary 19th century inner city neighborhood, like we have lots in our city. And it's interesting to see what is happening in such an area in this transition. What you see here is the natural gas grid that needs to be refurbished. All orange and red lines need to be replaced within the next 10 years. Then the question is, will you do that, or will you change to another electric heating maybe, or district heating? Then there's poor housing isolation. So if you choose electric heating, then you need a lot of extra electricity coming into these houses from the grid. In addition to that, there's all chargers coming into the city. So we need 6,000 citywide in such a neighborhood that is I think there's 25 chargers in this area to be developed before 2030. And there's additionally renewable energy, a PV solar coming in. This is already installed on a school, on a house, on another school, and then there's all the different PV solar installed in this neighborhood. And it all comes together in the powerhouse, which has a capacity of 630 kilowatts in this location. That's already been refurbished from 400 kilowatts into 630. And we see this all coming together in this powerhouse, that it might not be enough. Because if we count that up, it's a total of already, due to the energy transition, 570 kilowatts. Additionally, on top of 630 kilowatts. It's not all simultaneously powered in, and some is powering in and some is powering back, but it's to give an insight in what is happening on a neighborhood level if we do the energy transition. And it's really challenging for us, because we need to reinforce the grid on all locations in our city. So what we see is PV solar, EV, charging, electric heating, gives stress to the grid, and we need to do a lot of investment and reinforcement there. And that provides us with high energy costs. The grid operator made that into this picture in a study. What you see on the left side is all the powerhouses we just saw. One in the neighborhood, but these are 200 powerhouses in the western side of Utrecht. If there's just PV solar and electric heating coming in, then 25 of these 200 powerhouses need reinforcement by 2030. If we do add charging to that, then 50 powerhouses need to be reinforced. Then what we already do is smart charging. That helps a lot. Then it's called stupid or smart charging in an ordinary way, shifting the power from the day into the night, when there's enough grid capacity available. Then we only need to reinforce 30 powerhouses. If we do super smart charging, that's dynamic charging, measuring the capacity of the powerhouse, we only need to reinforce 25. So then we're back at the reference scenario. Then the extra capacity needed from the mobility, EV charging, is already solved. And then there's vehicle-to-grid charging. Then you can also solve a part of the grid connection that came about from renewable energy and heating. So that is really the holy grail to solve the grid congestion problems in our city. Now, why is that important for us to solve this? Because we are the city, the municipality. It's the grid operator's task to reinforce the grid. But it's also sort of our problem, because the energy transition demands a lot of space in our city. Our DSO made a grid analysis on how many of the powerhouses need to be reinforced by 2030. We have about 1,000 of these powerhouses in our neighborhoods. About 200 need to be reinforced or enlarged. That all has to be placed somewhere in our neighborhood, and we don't have enough space in our neighborhood because we have demand from a lot of other functions as well that also require space. So that's why we need to look into other solutions than just enlarging the grid, digging open every street, etc. this is the barcode. It's from our spatial strategy. And in red, you see, or in all the colors, you see all the different functions in our city that have a demand for space. And in orange or yellow, you see the demand for energy infrastructures. Now we need, if we do that in a smarter way, combining different functions, integrating them, we might save a little space, but still it's quite challenging to put all different functions in a dense city. And then the solution. Here's the king again. Yeah, so this was 2019. So in that year, or already earlier, but in that year we really started to scale up this vehicle-to-grid charging infrastructure in our city. This was the first of currently already 500 and more public chargers installed in Utrecht with the AC bi-directional function in it. It's installed by We Solar. We will shortly have a presentation of this system. It's here as well. We Solar developed this system in this demonstration area since 2015. This charger was ready in 2019 and scaled up that until we had 700 of these chargers installed. Then we have a consortium of many partners developing this system, and also the University of Utrecht is involved, and they calculated what is the potential of this network, of this vehicle-to-grid technology. And they calculated that with only 8,500 cars that are connected to this vehicle-to-grid system, we could power the city during a cold winter night, overnight. So storage during the day, renewables in the cars, power the houses in the night, peak demand from heating, and thus we don't need the reinforcements in the grid or in a less fast pace. And that's really promising for us. So this is the expansion of the network. Here, this is a charge square where there's, I think, 5, so 10 sockets in one location installed. Currently, you have already 700 of these V2G chargers installed, which is great. So we have the V2G network ready. Then we had one problem. There was no car. So we have been waiting from 2019 until last year spring for a car manufacturer to come and deliver a V2G capable car to our network so we could test the system further. And yeah, here it is. Luckily, we were happy to see that Hyundai introduced the Ioniq 5, which had the capability of charging vehicle to load. So it could power a coffee machine or your camping gear. But it did not have the ability to communicate with the charger. And we just had Lonneke here explaining us the communication between the OCCP, the grid operator, and the charge point operator. But you also said the most complex part is the communication between the charger and the car. And we were lucky to develop that together with Hyundai. So they did a software update actually of the car, implementing this communication standard 15.11.8 in the car, so that it can communicate with our chargers. I don't know if it already works. It's really complex. This charger does it. I believe we need to do another update in our chargers, on-street chargers, to make it fully work, because yeah, the standards, there's a draft, there's another version, there's another version, and another version, and then it doesn't match anymore. But we are working together, cooperating, developing this system in the hopes that it helps us to facilitate this energy transition that we really need to make as a city to just save the climate in the end. So that's my story. I have one more slide, Baerte, and that's an important one. Next year, or this September, the 26th and 27th of September, in Utrecht we organize the AVERE e-mobility conference, which is the European conference on e-mobility. 700 people from all different locations in Europe come over to Utrecht to speak about e-mobility and developments. So be very welcome to come over to Utrecht to see what is happening there in September. Thank you.
Thank you very much, Matthijs. For you, it's bidirectional charging, not a nice to have, but you explained it's a need to have for Utrecht. So the sooner, the better.
Sure.
Thank you very much. Now we're going over to the panel discussion and the question and answers, and that will be moderated by Yasmine. Yasmine, we've been collaborating many years. You saw another picture of our king with the Renault Zoe, and Yasmine is a former Renault colleague.
Yeah.
But now you work at AFRY as a principal. Maybe you can introduce yourself a little bit and afterwards invite the panelists to the stage.
Sure. Hi,
Applause,
everyone.
of course.
Good morning, everyone. It's a real pleasure to be here with Baerte, with many of you that I can recognize. We have started this V2G adventure from 2017, 18, and 2019 we had this first experimentation on bidirectional. And I'm really pleased to be here. So my name is Yasmine Assef. I am at AFRY Management Consulting for a few months now, about 2 months. When Baerte proposed me to moderate this day and some of the discussion, I was really happy to join. Before we jump in on the panel discussion, and we'll invite the presenters this morning, just a few words and remarks from my side on the global challenges and on the state, I would say, of the industry. We know that the transportation is generally representing 1/3 of the energy consumption and 1/4 of the global emission. So going zero emission for transportation is key if we want to achieve our zero emission goals. And despite the recent decisions of the European Commission on also opening to e-fuels because of some push from different governments, battery vehicle electric and BEVs are probably the most efficient and the most affordable solution for the green transportation. Even for trucks, even for heavy-duty vehicles, they will be very much efficient. And when I say affordable, is so everyone can buy them. And this is key if we want to go full electric. And that is why we will have so many, and we probably, I think that we all agree that BEV will make consensus and we'll have those millions of batteries going around here and there. And the question is what we can do with all these batteries. On the other side, some studies show that in 2030, we will need something like more than 400 gigawatt of stationary storage, or storage, I would say, in the world. That is huge, and that is 15 times more than what we have installed in 2021. So this need for storage, it's mostly because we have to go renewable, we have to have more renewable, we have to decarbonize the whole industry, usage will become I would say more electric, so we need these stationary storages, or this storage, I will not say stationary, so we need those storage. And I think that, you all agree that vehicle to grid will be and can be part of this 400 and something gigawatt of storage need. And we have this cost-efficient tool in our hands as OEM, as part of the ecosystem, as charge point manufacturer, so what we can do with that. Another final maybe reflection or remark, or another perspective of seeing the vehicle to grid is the use of raw material. We didn't touch that topic, really. We are here on making the you know, the things working, but raw material is rare. The European Commission has just announced the Critical Raw Material Act, and the topic is how we can secure the critical raw material inside Europe. I guess that in the North America is the same. It's the same. How we can be less dependent to third parties and third countries. What shall we do? And of course, there is mining, there is processing, then there is recycling and circular economy. Mining, we cannot invite mines in Europe. If we don't have it, we don't have it. Processing, we can do certainly something about it. Recycling, for sure we can do. And circular economy. Then we come back to vehicle to grid. Why can't we use this amount of, I would say, resource that are in our cars by doing something else instead of going from point A to point B? And using these batteries as storage is really important. That was my point, just to say that vehicle to grid can bring, of course, help to the grid, many things, but also it is an act of taking care of the resource in our world. So with that said, I am happy to welcome the panelists on the stage, please. Lonneke, everyone, yes, please come. I think that we don't have enough, or is that okay? Yeah. Please have a seat. Oh. I will maybe then start with... Thank you. It is easier. From the one who came from far, from Ben, with you, Ben. I'll start with you. Can you let us know a bit more about what we have heard on policy in California? Recently we had read some news here. Maybe you can tell a bit more about that to us.
Absolutely. So very exciting, very rapidly changing time for zero-emission transportation policy, for grid decarbonization policy, and I think growing recognition for the opportunity and critical role for vehicle-to-grid technologies in enabling both of those transitions. There was a bill introduced in this year's state legislature, so our state policy-making body, that is recognizing that important role and proposing to require that all of the chargers, all of the vehicles that are funded with public monies, so taxpayer dollars, ratepayer dollars, be required to have bidirectional capability within the next several years. This is, coming from our legislature to accelerate and really force our hand to make this transition happen. So will be very interesting. It's still very early in the legislative process, so individual members propose this policy. It goes to a policy committee and gets negotiated and updated. And so clearly at the Energy Commission, where we've been very keenly focused and interested in advancing this technology, we're keeping a close eye on how this particular bill makes its way through the policy committee, and maybe by this summer could have new legislation signed by our governor that really codifies the state's commitment to bidirectional charging technologies. So exciting and
exciting news, and yeah, absolutely. That was really, really something that we were maybe expecting or dreaming of, but never. But that was a bold decision from California, and so from you, maybe you can reflect on that. Do you think that in Europe we also have at one point force the car manufacturer, charging manufacturer to absolutely be bi-directional. What would be your view and your reflection on what's happening in California? You have already your mic.
I don't know if there needs to be a law on that, but what we do as a city is try to develop and move the market into that direction. Firstly, by providing space for in the demonstration area and on the streets for developing this kind of technology, together with Driivz Solar as a company. And as a second step, try to implement it in the concession contracts and tenders we put into the market. So make it a requirement to be for the charging infrastructure. We require as a city on the streets to be bi-directional. And we've seen before with other standards that by doing not only this as Utrecht, but by the hand of ELAT, doing this with all different tenders and that are put out on the market in different regions and cities in the Netherlands, you see that at least for the charging infrastructure part, the market is understanding, oh, apparently there's demand for this technology and we need to develop it if we want to win those concessions and sell our products. So in that way, we push the markets for certain standards and for certain specifications of charging infrastructure. And for car manufacturers, that's of course a bit more difficult for us because we don't have a direct buy of the cars. But then we seek to provide a sort of a test bed in Utrecht. Like we have 500 or 700 V2G chargers on street and asked OEMs, could you test here the development of your technologies? Yeah, there's an example here. On our infrastructure and be very welcome, and we organize a network and a cooperation with lots of partners where you can develop this technology in your cars.
Yeah, so you're more indirect, I would say.
Yeah, maybe a final outcome might be there's a standard or a normation for V2G for charging infrastructure, but there's a long way before that.
Absolutely, and we hope that other cities in Europe will follow your example. Lonneke, same question on what's happening in North America and in general more about, you were mentioning the importance of open standards and what is missing today. Why? Because when you talk about open standards, I think that we all agree that this is the way to go, but apparently we are not still there. And what is missing here?
Yeah, thank you. So what I wanted to add to the success and the scalability of bidirectional charging, of course, the legislative incentives or push is very important. Also, the OEMs, the car manufacturers developing cars that are capable of bidirectional charging. I think at the Open Charge Alliance we have hundreds of companies developing charging infrastructure, and we see there also is a lot of energy and a lot of willingness to develop bidirectional charging. I think where we could do a bit better is on the utility side. I explained about the grid codes, and some utilities are quite squeamish and are a little bit insecure. But I think they are inevitable, they are really needed to make sure that at a large scale bidirectional charging is being accepted. In the city of Utrecht, you're lucky enough to have a very open-minded utility company called Stedin, and they will do everything to make sure that we learn and this is enabled. Also in Japan, so there are a lot of utilities across the world who welcome V2G, but there are also a lot of utilities across the world who are either very scared or want to control everything. And I think when you look at the standards development, and I'm referring of course to OSPP, it would be really welcome if there were more utilities joining this open standard, open source development, and just explaining what it is that they need and help the industry get this on the road. So that would be my call to action to utilities. We have of course
EDF, great supporter of bidirectional charging and the Dutch grid operators, but we could do with much more utilities to help this industry learn and develop bidirectional charging in a way that utilities are comfortable with it.
Thank you for this action, call to action. Huh? Utilities, you have to jump in now. It's time. So we have 3 minutes for question and answer. The audience, if please, gentlemen.
We'll move around. Please, your name and the organization you represent.
Hi, I'm Rune from Monta. We are a back-end system or driving charge platform. So thank you for some great presentations, and I think it's really interesting how it can solve your problem in Utrecht with maybe even less than 10% of the cars actually plugged in. But I would like to hear more of when you go into rural areas and also when you have cars potentially having double the amount of capacity, so you cannot charge them over one night at home. So where do you see that this development in the rural areas? Do you think that this should actually charge at like more like gas stations today, or how do you see you incentivize the homes that actually plug in, right? Because right now you would maybe charge once a week, maybe eventually you charge once every 2 weeks. Where do you see that development, and what are you doing specifically in California to incentivize private homes? Thank you.
Thank you very much.
I'll start off. California is a very large state with a lot of rural, remote areas, and the private market is slower to develop and deploy infrastructure in these areas. So we, at the Energy Commission and our funding programs, have certainly started putting greater emphasis and prioritizing places where the market may not solve the deployment needs naturally or as quickly. We've been putting out both, DC fast charging, kind of gas station plazas in these locations, as well as slower charging level 2 incentives for homes and installations there. I think clearly a lot of opportunities for smart charging, charge management in those places, and also those tend to be places where our electricity infrastructure itself is more vulnerable, less built out, and so there's been greater opportunity, greater interest on backup power resilience applications of V2G, and maybe less near-term interest in market integration and participating in electricity system support, but more backing up power to your local facility. We continue to invest in this area, but I think it's it's slow and it's very different than the more densely urban populated areas such as Utrecht. Different motivations, different applications of the technology. Wouldn't claim that we have solved it by any means, but continuing to invest, and I think just fundamentally acknowledging the different context and the different environment faced by those drivers is, the first step that we can take.
Thank you. There were some more questions. Yeah. Hans, your name and your organization, please.
My name is Hans Welschen. I've been active for more than 40 years in solar energy and distributed energy generation. And my wife thinks I'm retired, but still active because it's such an interesting thing. My question is, at this moment, it's not interesting to have a battery at home because you can sell your energy to the grid very profitable, but that will change in short notice. For people having their own driveway and their own garage, it's no problem to have their car used as a battery, but in Lombok there are not so many driveways for the people, so they have to park in front of the door. Will you facilitate a behind-the-meter connection for those cars, either physically with a cable to the house, or just administrative, that you have some counters forward and backwards and calculate behind for the cost?
Thank you.
Yeah, there are some disadvantages to this private charging infrastructure on street. From an energy perspective, there are lots of advantages, but from a more public role, there are some disadvantages that we have to cope with, we haven't solved yet. So probably not private chargers on public street. Maybe the administrative solution could help. So you could have a different, bring your own service provider or your own energy bill to the public charger. That is a solution we look into, but it's still very complex, administrative to organize. Because you need to dynamic administrate your own bill to a specific grid connection. It might be a good solution, but from the grid perspective, it doesn't really matter. So it's more of the business case is better for the end user, for the homeowner, if they can provide their own energy into the public charger. From a grid perspective, what we do now in Lombok is we just measure the capacity of the powerhouse, and based on that capacity, you lower the power usage of the chargers. And if you do that via a private person or just on the public chargers, it's just one copper plate. It works. So the congestion problem can be solved either way. Might be even a bit more complex if you let that to a private house owner. So there are some advantages and disadvantages.
Thank you. Another question?
Last question before we go for the next block. Yes, 2 questions.
Thank you. So I'm Paul Bartolomeu from IT in Portugal. My question is, so we are now moving towards a world where we have vehicles at home that will help us during our daily lives. They will supply energy when the grid goes out. But that brings also the problem of adding cycles to the batteries and increasing the complexity of the system, and also, let's say, exposing more endpoints to security attacks. So how do you see this evolution in the future? Thank you.
Yeah, thank you very much. Maybe Lonneke, the topic of cybersecurity, and I know there's someone of Stellantis in the room regarding the life cycle, so we'll save that answer for a next block. But cybersecurity, floor is yours.
Yeah, sure. So information security is really important in all aspects of our life, and it's already important and will become more important in EV charging, since it combines transportation with energy. So it's definitely one of the main focus of many of our companies. And also speaking for OCA, we have security implemented. Quite recently, there was something in the news about people trying to test the system and see if it was actually secure, and we really welcome those efforts, because it's not just about specifying the security measures, but you should also implement them and check them and update them regularly. So it is a constant point of focus. It is something that we just have to face. You can't stay back. The world is moving forward, and information security is just something to consider, work together, and take very seriously, and we do. But it's really a key point.
Very good.
I have here, and question on battery degradation we'll save for the Stellantis presentation after lunch.
Hi, I'm Alex from EV Energy. I've visited Utrecht a couple of times. I love it. Lovely place. Just for context, I've struggled to get my local council in the UK to even install chargers. Utrecht seems to have a really holistic approach to charger installation, deployment of renewables. How did that journey start?
Well, what maybe helps is that we have a green and progressive city council. And also there's just demand from people wanting to charge their cars and saying to the council, you know, you want me to drive electric. If so, then I need to have chargers. And the council says, organize that for them, because we want them to drive electric. And sure there is some resistance from people not driving electric, saying, oh, you're taking away my parking bay. So that's always, we need to seek a bit balance between how many charges do we put on and how many on the amount of electric cars. But yeah, we now developed together with Equens, who's sitting over there, a data-driven rollout system, so that we put chargers really in locations where there is demand and we are sure they will be used, and that really helps to have to also to understand the people who are against the charges, to understand, oh, at least they're trying to do it in the most balanced and good way.
That is a very good transition, I think, to the next topic, which is the live demo, because it's a good transition, because I think that We Drive Solar and Robin Berg is one of the person at the initially pushing for those as well in Utrecht. So I think your question was a good transition.
Yeah.
Please, can we have an applause to our panelists? Thank you.
And you, thank you very much. We'll see you, Yasmine, at the moderating for the next session. We're going to set up a live demonstration because there's a lot of talks, a lot of PowerPoints, a lot of vision on e-mobility. But today, as Yasmine introduced Robin, we would like to showcase the collaboration between not only sectors, automotive and energy, but also entrepreneurs and engineers. So it's very nice to deploy an idea, but from a grid perspective, yeah, it has to work and it has to be safe and cyber secure, as Lonneke mentioned. So the next block will be a live demonstration where first Robin Berg, the director of We Drive Solar, the local entrepreneur behind the pilot in Utrecht, will showcase his vision and what he does and how he collaborates with the municipality and the grid operator. But since the grid operator wants to be very secure that everything is safe and tested, the second part of the this block is the demonstration by Thijs van Wijk, our manager test lab, who is assisted by Robert, Italianer. And they are going to show what ELAD does at the test lab on bidirectional testing and developing. Robin, first, may I give the floor to you and show us what you're doing in Utrecht.
Yes, thank you very much for the possibility to give a small update on the Utrecht project. You already heard quite a lot. I will maybe show some pictures you already have seen today, but I'll tell a different story when showing them. So this picture you saw, this is actually one of my installations in Utrecht. We installed 10,000 solar panels on 25 school roofs, and that is how the project for us began, with solar. And as you maybe have read, solar in the Netherlands is really going literally through the roof because we are installing massive amount of solar as we speak. We have more solar in this country per capita than in Australia. So we are already have more solar than Germany per square kilometer. So it's really, even in a country as north as the Netherlands, solar is really a serious option. And when we installed these panels, we already foresaw this future and said, we have to think ahead of the game and see what is needed when you have so much renewable power in your grid. And that's why we already in 2015 started with the concept of bidirectional charging. This was actually my first car I bought 11 years ago. The first mass electric produced vehicle from Nissan. And I read about that it was used in Japan for bidirectional charging after the blackouts after the Fukushima disaster. So I contacted Nissan Europe and asked them if we could get one of these chargers to Europe and adapt them for the European grid. And that's what we did. And we were very happy to be one of the first to test and see what this technology of CHAdeMO and more importantly bidirectional charging could mean. And basically for me it meant that I was having a lot of solar. I had my company, my office, my home behind one grid connection, and with this car I was able to run it on solar for 24 hours a day. And then I got into contact with Steden, who said, what are you doing? This is very interesting. You're peak shaving already. You're getting the solar off the grid and you're charging your car with it and you're using the battery for the peaks during the night. So the collaboration started. The great thing about this collaboration is there's a real ambition behind it. Utrecht is quite serious about becoming the first bidirectional city in the world. And I hope that other cities will challenge us on this, because we really want, in the end, not of course to be alone in this, but we are very ambitious to demonstrate what we can do. And the collaboration of the local governments, the region, the grid operators, local companies, to have a strategic vision to roll this out, has led to, again, we are very happy with this king. He is very into technology and new stuff. But if you don't look at the king in this picture, but you look at the charging station and the cars that are there, I know that's hard, but if you do, then you see the first implementation of 15.11.8 in a public charger and in a car worldwide. And this is just a draft version. That was the only thing that was available. But the great thing is that it worked. The bad thing is that 15.11.8 has now been proven finally, but it's completely different now. So we can't use these cars anymore, and we cannot use this old draft version and update it a little. We have to really make a next step, and I'll come back to that later. But the great thing about this demo is that it gave us the possibility to roll out this technology all over the city and to be V2G ready for the future. And that's really what we want to do. We want to build out the infrastructure so when the cars come, we are ready. So we have now a lot of chargers in the streets, thanks to Matthijs and his colleagues. We have a lot of chargers at companies in the region. This is at Triodos Bank. They built the largest charging plaza in the world in 2019. But not for long, too bad for them. AVERE insurance company asked me how much installers do I have to install to become the world's biggest over that, and I want to behold that position for a few years. So we told them at least 250 you need to do, so they did, and actually at this moment we are installing 50 extra to keep ahead of the competition. And of course both of them with a really nice solar roof on top of it. And the solar combination with charging of course makes clear immediately what is the purpose of this bidirectional charging. And then already mentioned, we got into contact with Hyundai, and then we went from prototyping to production. And for us, this of course is a major step because that's the last step before mass implementation of the technology. And the great thing about this car is that it's a normal production car and only the software is adapted. The bad thing is that it was launched before the final version of 15.11.8 was approved. So we don't have the final version in this car. And because of that, it only works with a special charging station from Korea. So we didn't develop this ourselves, although my logo is on it. We bought 25 of these together with Hyundai to demonstrate how the technology works when it's almost ready. And the last phase we are entering now is to bring the standard to its final version, both in the car side and in the charger side. But the great thing is that we now can integrate this into our back offices, test OSPP, test all the standards, see what happens to the grid when you start discharging, and not with just one prototype, but with production approved vehicles. And that's exactly what we're doing. So last year we had the world premiere of this technology in Utrecht again with 25 cars. And those cars are now in operation in Utrecht as shared vehicles. And we are now installing these chargers at multiple locations in Utrecht to have different use cases and apply the technology. For example, in new housing projects, we are working together with Synchroon, who is developing a Wisselspoor, a new housing area, 1,500 new houses. And this is part one, it's already been built. And today we are installing 2 of these chargers in the parking garage. We covered it with solar last year, and we already have the cars being used there by the people who live there, and we will start testing the V2G technology within the car sharing program we are operating. The same will happen in Cartesius-Driehoek, also a huge housing development in Utrecht, where almost 3,000 new houses will be built. And we are planning to install at least 100 bidirectional chargers there as well. So this is the rollout we are envisioning. Also at AVERE and Triodos we are installing these chargers in this period. So we have different use cases to test with. And then the major question is, of course, why are you doing this as a company? What's your gain? What's your business model? I know you want to be friends with the grid operators and ELAT, and I like Baerte a lot and Steden, and it's all great. But why are you doing this? And my answer is this graph, basically. So, especially in the recent 2 years, this has become more and more interesting. But already before that, there was enough room within the electricity prices, day-ahead pricing, to make money with smart charging and bidirectional charging. And this is actually the graph of yesterday. And this is quite special because only recently, on a workday in the Netherlands, we have negative prices because of wind and solar energy producing a lot of energy. So this was the yesterday picture. It wasn't really that sunny. There was sun, but there were also a lot of clouds. And we are just at the beginning of the installation of solar and wind in the Netherlands. We are going to double it, maybe even triple or quadruple it in the coming years. So you can imagine what will happen during midday or during the night when there's wind. So the duck curve will be the same, but we think that the differences between the peak and the low end will be very interesting and remain interesting in the future. So when I charge my 50 kilowatt hour battery during the midday and then discharge it during the night, yesterday I could make like 20 euros in one day with a car. So if you do that like 30 days on a row, you're driving your car for free. So that is the business case. And that is just with charging. If you are able to discharge it in the morning and you have a big battery of like 100 kilowatt hours, then you can double that. And the great thing about bidirectional charging, when the car is fully charged and not being used the next day, you don't have to wait for someone to drive the car. You can continue the smart charging and bidirectional charging. So both from a car sharing perspective as we operate, but also from private users or fleet owners, this is becoming a very interesting business case. And when doing that, we connect our system to the grid operator and said, yeah, maybe I have a little congestion during that time, so please don't activate all your cars at once, maybe shift that a little bit. So we do the smart charging in in close collaboration with the grid operator to make sure that there's no new congestion caused by us. So we reckon the grid congestion and the capacity that's available and give the grid operator time to invest in a network for the electrification of all transport and heating. At the same time, when you look at this curve, and you know that there's an energy crisis going on in Europe, and also a war in Europe, you don't want to charge your car here, not just for pricing reasons, but also because we know that during this peak hour, there's a lot of gas being burned to get the power to our houses. And we want to get rid of gas, as natural gas, as fast as we can. So this graph really puts on the table all the common interests we have from the grid perspective, from the car owner, from the fleet owner, from the CO2 and geopolitical wishes. And we think that this is the future, and with bidirectional charging, we can enhance this future and bring it here. So that's a small update on Utrecht. We do this smart charging right now on all the charging stations we have in the city, operational. So we didn't ask for the people charging if it's okay to do that, we just do it. And we get very little negative feedback, so people find this is okay. And I have to mention that we are not selling yet with dynamic prices, so we have a fixed tariff. So even with a fixed tariff, people are already okay with that we are doing it. We are not able yet to share the benefits. That's the next step we are doing. The charging station has gone into production. We have an investor who is now building a new factory here in the Netherlands to bring this bidirectional charging to mass production. We are very happy with Equans as one of our clients using this charging station for the Rotterdam region to roll out in their projects there. So we will bring this charger to the market together with Nieuwe Weme, our partner who produces this charging station here in the Netherlands from the Kolen group. And now my mouth is a little dry. Thijs, enough talking. Can we get something to drink maybe? Is there something we can do?
Yes, we can.
It's demo time.
The moment you have all been waiting for. The demonstration.
So a lot of innovation is going on standards and protocols. Lonneke mentioned tendering. Matthijs mentioned building the charging stations and the back office behind it, and learning how the customer reacts on this. Robin mentioned. Now you're also part of an innovation because, well, we all know the PowerPoint presentations and pictures of how stuff works, but we're here at the test lab and we would like to show you what Thijs and his team are going to test, not only the Hyundais, but other car manufacturers and charging stations in the coming years, how it should be done. Floor is yours.
Yeah, thank you, Baerte. So, well, Baerte already introduced us, of course, but well, my name is Thijs van Wijk. I'm running the daily operations at the ELA test lab. And Robert Italiander, one of our test engineers at the test lab. And we're now going to do a little demo. Does this work? No. It's not connected to this one, of course. So, yeah. Just have to do it at the laptop itself. So first of all, we would like to show you a small demo of vehicle to load. Actually, Robert already did it a bit. A vehicle to load is a way to get power from the electric vehicle to power up a device or multiple devices. That's nice for if you're on a campsite, for instance, or if you want to do a more luxurious picnic, you can get some power out of your car to, for instance, make a cup of tea, of course. And what do you need for that? First of all, a special plug, in this case, which on the one side has a connector that fits into the vehicle, and on the other side, actually just a regular wall plug. And the converter in the vehicle creates a 230 volt 50 hertz grid connection with about 5 kilowatt of power, actually like a regular wall plug. And the tea is brewing, so It's as easy as making a cup of tea. You just get your vehicle connected and start cooking. And it's actually cooking. Maybe you can hear it in the audience can hear it.
I can really recommend a cup of tea from a Hyundai car.
Yeah. But that's just vehicle to load. Because vehicle to grid, that's another ball game, because that makes the things a bit harder. Your converter does need to attune to the voltage, the phase angle, the frequency of the electricity grid. And it also needs to comply to local grid codes. The local grid code for generators is also Lonneke already mentioned. On DC, this was already a possibility using the SHA-DEMO protocol, but for CCS type 122, that wasn't available yet. But now, thanks to the ISO 15918-20 protocol, that has become available too, and both to AC chargers and DC chargers. And this will now be shown. So we have now connected the Hyundai to the Signet charging station, which has been set to discharge. And it's discharging via our Keysight grid emulator. And I can now show you the power on the grid emulator. And now let's zoom in a bit. Oh, yeah. Can we switch to the laptop again? Yeah. And there it is again. And here we can actually see that we're now, the active power has a negative value, so we're actually delivering power back to the electricity grid. So now our lights and our screen are powered by the vehicle, and not only brewing a cup of tea, but we're actually supporting the grid over here.
Yeah, actually, we're here in a room, but this is also live streamed, and a few hundred people are watching on YouTube in different countries. And one of the questions was, is this really or is it still fake, Thijs?
No, we're truly doing this, indeed, yeah.
Yes, because you could see the parameters going up and down and constantly adjusting a little bit to the frequency of the grid and the voltage. Huh?
Yep. Yeah, and we can keep the demo running. So if people here want to check if we're doing it for real, we can do that after the presentation. We can show you how it's working.
We are actually making money with this car already, yeah? So,
so let's continue on. So this is just like a first step, a first demo, of course, because, well, much more is needed to implement this on a larger scale. In the first place, well, a lot more electric vehicles and charging stations need to implement the ISO 15918-20 protocol. And actually all the other standards and protocols being used in the eco-mobility ecosystem needs to upgrade to be able to handle bidirectional charging, the specific messages that are needed for that. And of course the grid codes, they need to be, well, maybe at first integrated in the charging stations, like a fixed value, but if you want to make it flexible, which would be handy for, because, well, an electric vehicle will be driving around, of course, visiting different countries. So if you want to comply to the different grid codes in the different countries, it would be nice if you will be able to send the grid codes directly to the converter of the vehicle at any given location. So you need to set up communication for that. Like actually, Lonneke also made clear in her presentation, you need to set up communication from the utility using the IEC 61850 till with the OCPP to the charging stations via 1508-20 to the converters to comply to the local grid codes. And most importantly, actually, Robin also showed that you need to create value for the customers to, well, make their vehicle into a battery power station and make it valuable for them to do so. And there will actually also be a presentation on that later in the afternoon at 3 o'clock, focusing really on the different players in the value chain. And of course, was the most important part, you need to test all this. And with that, I would like to continue on with a presentation about the ALAT test lab, where you are at the moment. And our test lab, well, you've seen it. It's a big location, 900 square meters. And because of its size, it's suitable to test all kind of different devices. Not only just passenger vehicles, but also trucks, buses, well, digging machines, you just name it. If it has a plug and it's a vehicle, we can test it. And we can also install bigger DC chargers over here. We also have more power available to test with these DC chargers. More power than we had in the past at our previous location. So we already have all kinds of different AC and DC chargers. Well, a lot of them are, we had to put them outside, of course, because of the event. Normally they're inside. You can see a couple of them over there. A lot of some chargers here in the background, and we've got far more of them. Multiple high-power test spots. The black boxes on the pillars here are connectors with maximum amount of power of 125 amps, and we're now in the progress of installing a new testing system we have acquired from Keysight. It's a 360 kilowatt testing system, which allows us to create a clean grid of 360 kilowatt of power, emulate an electric vehicle or a DC charging station also on 360 kilowatt of power, and on the other hand also emulate a DC emulation of 360 kilowatt of power, so we can also not only test the communications, but we can actually also test the whole power flow from a DC charger or an electric vehicle, and feed the back power also back into the grid. So during our testing, we don't lose the power, only maybe some efficiency losses, but it will be hardware in the loop testing. Now those devices look like this. Before grid emulators, one is being used in the demo at the moment. We get 3 or more of them. The communication testing, the charge discovery system from Keysight, and 2 big DC loads of 180 kilowatts. And we're pretty proud of having them, so because they're going to help us. They're going to help us with testing the tests we perform. Now, what are these tests that we're performing? Actually, 6 types of tests we do. First place, the interoperability test. It's also the reason why we have so many charging stations over here. We tend to acquire, we tend to actually ask all manufacturers to install their charging station over here, so we can test their functionality on the different types of electric vehicles that we're also getting over here, to test if vehicle A is able to charge on station A, B, C, D, etc. And we do that for AC chargers, wall boxes, DC chargers, as long as they are able to communicate via OCPP, and we're able to do smart charging profiles on them. Because that's another test we do, smart charging test. During the smart charging test, we dive deeper into different types of smart charging scenarios, changing the maximum amount of current multiple times in a row, for instance, setting the maximum or the minima that are allowed, doing pauses in between, and checking if a vehicle or charging station is able to cope with these kind of scenarios. During this test, we do detailed measurements of the power that goes into a charging station or an electric vehicle, and we do this on a really detailed level, so we can see the power quality impact of the charging on the electricity grid. And not only the more regular power quality impacts regarding, for instance, harmonics or power factor, but also new kind of phenomena like superharmonics, which are frequencies in between 2 and 150 kilohertz, and where standardization is still limited. And we, with our tests and research, we try to gather more data about these kind of distortions and what they do on the grid, and where eventually limits should be at. Apart from doing these kind of emission checks, we also test the immunity of the devices to power quality issues in the grid. So we can use the grid emulators to not only control a completely clean grid, but also to create a distorted grid. That way we can see if, like for instance, an electric vehicle is able to charge if the voltage isn't 230 volt, but it gets higher, like 250 volts for instance, because there's a lot of solar panels that are giving power back into the grid. Or when the voltage is lower because a lot of vehicles are charging at the same time. Well, then there's the cybersecurity test. That's a test during which we work together with the ENCS as an organization regarding cybersecurity, and we can do an audit of, or facilitate an audit for the communication of, well, any kind of device in the e-mobility ecosystem, and any kind of protocol, of course, between these devices and systems. Then there's the grid operator test. That's a test that's important for the manufacturers of charging stations, of public charging stations, because it goes into the the grid connection of the charging station to the electricity grid and where it needs to comply to. So we do a certification check on that for at least for the Dutch grid operators. Every AC public charging station is being checked on things like the ability to install the charging station in a correct way, in a safe way to the grid, and install the smart grid, that there's enough space also to install a smart meter, for instance. And last but not least, the ICT chain test, a test where we test the whole communication in the e-mobility ecosystem. So what we do, we're not looking into the different we're actually mostly checking if the communication, if the data, if the information in system A gets to the other end of the chain. So, let's say system D, in the right way and is understood correctly. So it's not only about checking if the communication between the different systems works, but more about the information flow. If the information eventually gets at the right way at the right spot, and is understood correctly. So, for instance, if we send a 1 at system A, but it's in centimeters, will it also be understood as 1 centimeter on system D, or will it be understood as 1 inch, for instance? So, this is a thing we do in the ICT chain test. And now, we're adding V2G to our tests, of course. And what does that mean? Well, on the one hand, we also don't know that fully yet. For us, it's also a new thing, of course, a new phenomena we're also including in our testing program. But first of all, well, we now have the charge discovery system for Keysight that supports it. We have stations that are supporting it. We get vehicles that are supporting it. So we're going to test and gaining experience on it ourselves to see what's important and where the issues might arise. Then when we have more knowledge about it, we can do the pre-normative testing of vehicles and chargers on their 15.8-20 implementation, vehicle-to-grid possibilities. It's important to know that we're not a certification lab. We're a test lab that helps the different parties in the ecosystem to develop and better integrate, to develop these kind of protocols and better integrate the devices with the electricity grid. So all tests we do are, pre-normative, as we name it, and are advisory. Then during the interoperability test, the smart charging test, the power quality test, the power quality immunity test, we're now doing that just solely on charging, of course. But when we can discharge, we can do those on discharging too. And when we discharge, we also need to comply to the grid codes, of course. So we'll also be testing on those. And lastly, the ICT chain test might contain new kinds of systems, because, well, you might be more connected to the utility, for instance, via the 61850 protocol to get these grid code information. So you also need to add that system to the ICT chain test. Might also be new messages. So also those will be added. And probably more things we didn't think about yet. And that's also a question for the audience, of course. If there are anything that you think or foresee would be a good thing to add to the testing program at ELAD, regarding vehicle-to-grid, but maybe in general, and please let us know, of course. And not only for that, but also if you want more information about the tests. If you want to add a station, maybe even a vehicle-to-grid ready station to the lab, or if you want to have your vehicle tested, you're also welcome to contact us, of course. And lastly, we didn't create a test lab on our own. I also would like to thank some of the organizations who helped with funding the test lab. The Ministry of Infrastructure and Water Management, the province of Gelderland, the province where you are here now, and the joint Dutch grid operators, of course.
Thank you very much, Thijs. Yasmine, shall we do a little panel? And, little panel and some Q&A by the audience. One extra remark Thijs didn't mention, because this is in the benefit of the Dutch grid operators and municipalities such as Utrecht. So testing is for free, yeah?
Yeah, testing is for free, indeed. Yeah.
Excellent. Yeah. And we can also have a good lunch after the testing, or is it not included in the test?
Well, today we can.
Today we can. So thank you, gentlemen, for this nice presentation and demo. I'll start with you, Robin, and what you have done lately. And you mentioned that that still the 15.11.8 was not really, at the end when you have started this. So my question would be, what was the challenge here to integrate this car into the power grid? And what is, do you have to upgrade, and what do you plan as upgrade? We have heard from the city of Utrecht that we have now 700 charging points installed. So at one point, I guess that we have to upgrade all those charging points to have the latest version of which and which protocol. So what would be your position here?
Yeah, well, it was a pity that it took longer than expected to get the standard in place, but that's normal with standards. Takes time. And now the standard is here. It's also quite difficult standard from a technological perspective. So it's not like an easy fix or a small update on the work we have done. And that so now it takes a bit more time to get it into the charging stations and the production cars. But at the same time, it gives us time to scale up smart charging with all the blocks that's needed to have this ready for a large-scale implementation. So you need the right communication between the charger and the back office. So OSPP needs to support all the parts that you need for charging, smart charging, and bidirectional charging. So you have to be able to do that. So we need OSPP 201 for that. And that also isn't completely ready in the market yet. So therefore, I think end of this year, beginning of next year, we'll get a great momentum that the standards to do the whole chain, also OSPI, we're using that also in our communication between the aggregator and the back office. So the aggregator will be sending the charging profiles to all the chargers all over the city. And that also has to work seamlessly. You don't want any complaints from people charging there, especially if you want to implement bi-directional charging. But basically, we've done it all. So we've done smart charging, we've done a large-scale rollout in the real world. We are using dynamic pricing to do that. We have a connection with the grid operator. So basically, everything is in place. And now the standards need to maybe upgrade here and there a little to make it to the final level, meaning bi-directional charging. But for us, right now, that doesn't seem like a very big step anymore. So, I mean, we're already making money on smart charging. We already see the future when we can share this profit with the end users charging at our charging stations, or the shared vehicles using these charging stations. So basically, for us, the last step is a small step in the end. I know it's a big step on the technology side, and everyone has to still do a lot of work. So we are pushing together with Hyundai Netherlands to Korea. Okay. We are pushing to Renault. We were pushing to Sona Motors, but unfortunately they won't bring the car to the market. But today we have also a lot of other partners involved in the Skill project, like Stellantis maybe coming on board, and Polestar. And so the interest in this technology is growing, so more and more partners are getting on board. You see also in the charging station market that we are not alone anymore, and that's also exactly what we want. Yes, we want to be in the front, but we use an open standard. We have not patented anything, because we're doing this to go to a renewable society and make some money, of course, but that is in the second place. So yeah, I think that's
very good.
That's where we are.
Thank you for your optimism, and we'll make it. So maybe before, I have a question for you, but probably there is a question on the audience, so priority to you. Any questions?
Questions by the audience? What? Yeah. Who are you and which organization?
Hello, I'm Alex from Monta as well. You've mentioned that you have used the pilot projects for peak shaving or generating some revenue stream. What is the long-term solution, or what are the applications you see vehicle-to-grid being used? Is it frequency regulation, congestion problems? Where do you see it in a longer term?
Well, for us, the reason why we started this is that when you look at the renewable energy transition, and we're seeing it already today in the Netherlands and other countries, and California, that there's so much renewable going to the grid, and we're just starting. So it's already, I mean, the Utrecht region is already completely congested. So you're not allowed to install new large-scale solar panel installations. When you want to have a large grid connection, you can wait until 2029. That's today. So it's not like we're talking about the future, but the urgency is already here. And we're just getting started with the energy transition. I mean, only 25% of the Dutch electricity is renewable. And we have to go to 100. So you can imagine what this will mean for the coming years. And then when you look at the energy from a broader perspective, we see that batteries are the main help there. Yes, hydrogen will play a part and other storage solutions, but for the short cycle, batteries will be the main solution. And when you look at batteries, 95, 96, 97% of the battery production worldwide is going into cars. So that's where the batteries are going, and we need them soon, not in 10 years when we are ready with the cars and we start producing batteries for standalone options, which are also interesting. But the mass production of batteries is going into cars. So when you look at humanity going into solar and wind, and all the batteries go into cars, that's what my long-term perspective is. We will be using these batteries to store renewable energy when there's too much, and give it back when there's too little. It's that simple. And yes, there will be some money made, and yes, we will help the grid operator, and yes, we will help other goals, but that's the main goal: save humanity from global climate destruction. Thank you.
Thank you. Yeah, after this comment, it's complicated to continue, but still, there we have a another question: how to save the planet? Another question.
Are there more questions, or if everybody hungry for lunch? 2 last questions. Yes.
Hello, Andreas Safiropoulos from Unis Energy Group from Greece. What's your opinion between AC and DC V2G? And since you are an EV charging manufacturer, why are you opting for AC, or what are your plans there?
Well, the main question...
Sorry, I mean, you mentioned that you are waiting for the cars, and maybe if you go to the DC, maybe it's a faster approach for you to not wait for the OEMs.
Yeah. No, the main reason is that the grid operator has an AC grid, and Baerte said AC, no DC. No, just kidding. No, it's about scalability. So I had an interesting discussion also yesterday evening with the representative of Lucid Cars, and AC charging is the large-scale solution for charging. So yes, for fast charging it will be DC, but for at-home charging at work, at streets, at parking garage, it will be mainly AC. You will see some DC there, but it will be mainly AC. And that's also the location where you have time to do bi-directional charging. So when we made an offer for the AFRY insurance company for the largest bi-directional charging plaza, they already had an offer of another supplier for DC. And our solution was like 3 to 4 times cheaper. So for the large-scale rollout of bi-directional charging, and to be accessible for a lot of people, and I think it will be AC that will be the hockey stick curve. Yes, we will also need DC, because for specific use cases, DC is better, easier, maybe sometimes cheaper. So we need both technologies. But I think for the acceleration of this technology, AC is the way to go. But I don't want to have an AC-DC war on this. We had it in the future, in the past, and that's not good.
Thank you. Another question in the audience. Who are you?
My name is Ricardo Pelarella. I'm from Greenogenic. I'm actually coming in from Melbourne, Australia. So we have a bit of an interesting power system at home in that our renewables transition is now quite advanced. We never had a nuclear baseload. We've withdrawn a lot of synchronous thermal baseload at the moment. And we have, as alluded in one of the questions over here, a very strong and rising need for primary frequency response, which on the one hand, we've had fast markets, so under 6 seconds response, which EVs can do quite well and with very good investment efficiency, though we've regulated in a different direction to go for very fast frequency response, a 1 second market, which is very practically and reliably difficult to make out of EVs, and has created a proliferation of stationary energy storage, which raises an interesting tension for regulators and policymakers. Does the panel believe that, let's say, federal level power systems should have a greater proliferation of PFR supplied by cars at slightly slower response, so greater volume but slower response because it can cost less and be more accessible, or faster response, focus on system security in a more classical manner, which could defeat a market for PFR as provided by vehicles?
Thank you very much. Question for the panel, but be aware that in the afternoon session also Terna, the Italian TSO, will present, and they probably have a vision on this. Panelists.
Thijs, do you think it can be done with cars, primary reserve?
Yeah, it should be. They're responding fast enough, so that isn't an issue. And if you have multiple of them, because you need to have a certain amount of power, of course, but looking at the amount of vehicles that are already on the road, yeah, it should be achievable indeed. It really depends on if you can get enough vehicles to join, and for that to do, the consumers themselves must, well, also agree, must step into vehicle to grid, of course. So it must be interesting. It must be made interesting for them, and then it will be, yeah, technically achievable.
Yeah, I think so too. We are operating two Tesla power packs in Utrecht, who are in the primary reserve. And yes, those batteries are lightning fast, so they can really respond really fast. But you can also use them as the first responder, so to get it going, and then the cars right behind that to be able to be fast enough for the request that's been sent out. And then the cars start up a few seconds later.
Thank you very much. And in the be aware that in the skill project mentioned with Polestar and Hyundai and Renault, City of Utrecht and other participants, also Equigy, the collaboration of European TSOs is involved for frequency control. A last question for this panel. Who are you?
I'm Rudy from Switzerland. I'm 33 years in standardization of EV charging. And now my question is why AC V2G isn't supported by the OEMs, only with exceptions.
Well, that's not my experience. Maybe some German car makers are a bit hesitant, but my experience is that they all come to Utrecht and said, can I also be part of this project? Or they come to Baerte and say, can we please, and to Thijs, can we please bring a car to test, because you're doing such nice things in the Netherlands. So it's technically harder to do AC from the OEM perspective, especially. But once the onboard charger suppliers don't mind and are supporting this technology, for example, vehicle to load is now a big driver of OEMs putting bidirectional chargers in their cars. So especially the Chinese OEMs are offering vehicle to load at a massive scale. And they tell us it's only a small step to do AC vehicle to home or vehicle to grid. So we don't see this. Yes, we see that there are car makers hesitant, but at the same time, that are also the same car makers that are still promoting e-fuels. So
I think that this afternoon there is a session with the vision of OEMs, and I think that this is a question we can also ask. And just one additional remark, probably for my past position, but OEMs have a lot of challenges today of going electric, of going digital, and technology-wise, you know, there is a 3, 4, 5 years delay before making a car, so you have to plan everything in advance, and so challenges are here, and but suppliers are getting ready, so AC bidirectional will be easier as well. So give some time to OEM. They are like, in French we say like diesel cars, meaning that they go slowly, but then they go very fast. I mean, they start slowly and then they will go very fast. So I think that they're able to make it very soon. With that, I think we don't have any more time, but for other questions.
No, correct. So thank you very much for the demonstration. Also, thank you, Robert. And another thing, well, we connect people to the grid as grid operators, but this is also an excellent opportunity to connect people, have a sandwich, but also talk to each other, meet different people, different sectors, and, well, think about what next steps should be done. Have lunch. Okay, last people take their seats. So we can start with the afternoon session. This morning we had some demonstration, of course, how it works or what steps we have to take in future protocol development and what we are going to test here in the test lab to embed the new technology really seamlessly for consumers and OEMs. We talked about what governments can do, California, and how it should be implemented and tendered by municipalities, and what grid operators thinks are the goes and the no-goes. But of course, vehicle to grid is nothing without vehicles. So this afternoon we'll kick off with a panel of 2 car manufacturers, 1 backend provider, and European platform for e-mobility with a lot of OEM members. But first, I would like to give the floor to Diego from Stellantis.
Thank you very much. Okay. Well, my name is Diego. I'm a PhD researcher at Stellantis, and my mission in research is to investigate about vehicle-to-grid business models. And when we think about business models, it's basically all about value creation. And when we think about how V2G or V2X creates value, it's because the charge or discharge is smart. And what do we mean with smart? It means it's not worth or will not create value if the charge is done at the peak time, or we will not create value either if we discharge when we have high production of renewable energies. And I consider this as asking this question to all of us: how smart should V2X be to create value? I think, from my perspective, and this is not an exhaustive list, it has to be smart enough to satisfy environmental needs, which are 2. First, to decarbonize the electric grid, and second, to limit battery degradation. If we think that V2G impacts battery degradation, we should also think that there is a cost of CO2 associated to it. So this is something we should take into account. But we also have some economic needs to respond, such as have a reliable and efficient electric grid, have a reliable lifetime of the equipment, and to enable EVs owners' mobility needs to be satisfied. So what makes V2X smart? In general, it is some sort of information that goes from the electric vehicle to an algorithm, and then a response from this algorithm to the electric vehicle. But what do we need What do we need to be smart? We need 3 things. First, to have some embedded communication capabilities. This means that sensors that are telling the algorithm what is happening. We need to have an interoperable system that allows that different actors exchange information. And we need to have particularly information, which are the little pieces that will make our algorithm and our signal smart. And this is what we define as a network flow of information, which is what will make the value of vehicle-to-grid at the end. So what network flow? I asked myself this question because it seems that it's pretty complex to agree who is going to send what information and who is going to operate the algorithm. So here what I show you is a small plot of different actors from different articles in the literature, in the academic literature. And what it shows is that we have a diversity of network flows. So we have a different diversity of who will control the algorithm and which actors needs to be involved to create value. So, and this is how I'm going to leave you today. Deciding how smart V2X in general is a weak problem. A weak problem is a mess of a problem, hard to analyze which are the causes and the consequences. So first, we need to think that network flow and algorithms are going hand to hand. If we think about vehicle-to-grid business models, about fabricating the right signal, the algorithm that you use to fabricate this signal to tell how to charge or discharge will be highly interrelated with the network flow of actors who are going to send information, and in the decision to what are you going to forecast and what information you're going to directly measure. And at the same time, we should consider that this process of network flows changes what actors know. And by changing the network flow, we are also changing the reaction and the behavior of different users. For example, thinking that electric vehicle owners will behave the same way as today, with once a vehicle-to-grid business model is implemented, might push us to think in a different way to assess what is the optimal business models and which is the optimal smartness that we want in our electric vehicles. So I think that for really assessing how smart we want V2X to be, we need to have an iterative perspective. And in this sense, I salute what the project Scale is doing in a sense of trying to push forward for different business models and different use cases for vehicle-to-grid. Thank you very much.
Yeah, thank you, Diego, for your presentation. There is still some research and nice things to be done before it's a reality. We can see it. For this afternoon panel, if you agree, Mr. Baerte, what we can do is just start from a few questions, then pass to Christiaan, questions to you, questions, and then we'll have a discussion and a panel discussion, if you agree. So is there already some questions for Diego on the smartness of V2G, this iterative process?
Some questions for Stellantis, yes. Could imagine. Hi. From Greece.
Yes, so I'm really curious if on those 53 different topologies that you have done, if you have done any kind of comparative analysis with pros and cons and showing from different perspective of an O&M, an EMSP, a CPO, an EV charging manufacturer, a utility, a grid operator, who is favorable against the others. So if you have done this kind of work and it's shareable, it's really interesting for all of us to see it, I would say.
Yes, thank you very much. So normally, because these are theoretical work, everyone achieves the same satisfaction of needs. However, the assumptions taken to satisfy these conditions are different. So for example, if we assume that we are going to have one grid operator deciding how much vehicle-to-grid is going to be, how much electricity will be discharged from the electric vehicles, then we need to assume, to be sustainable, that he needs to know about the battery degradation, he needs to know about the mobility needs. And that poses a problem of how to fill this assumption in reality in a business case. If we go the other way around, if we think, let's put all our desire in environmental and economic needs into a price, so everyone can independently, decentralized, decide what to do, and like this, you don't need to know mobility needs, then this price needs to consider many other parameters. So basically, it's you give or take complexity into the amount of information you want to assume, but at the end, what we all want is that in different conditions, you will have the same environmental or economic performance in a given way. So the question now, it is, which are going to be the technological developments that will push us to having one type of network flow or another type of network flow of information? Is the prediction, the predictability of mobility easy to measure? For example, as in fleet cases, in that case, you don't need to have an information system to collect data from the mobility behaviors, because you know that they are going to be from 9 to 6. And if you want to include all the electric vehicles in Netherlands, for example, then you might have to think, what are you willing to give away in information and what you're going to assume as constant?
Okay, thank you very much. Are there more questions to Stellantis? Yeah. From Shell. Who are you?
Hi, I'm Yunhe. I'm also finishing up my PhD in TU Delft, looking into EV and grid integration. So it's amazing that you summarize all these 53 different network possibilities. So I'm wondering, do you have already a proposed method that really flexible can adapt all these 53 possible communication possibilities, and then that smart charging can really use in any possible ways?
At the end, I think from a car manufacturer perspective, we should try to develop a business model that is able to adapt to most use cases. From an ecosystem perspective, what I think I would try to contribute is to, when we think about the complexity of implementing V2G, sometimes we think about, okay, V2H, V2L, where is the charging point, the charging station? But I think it's more about what information are we assuming as given or not. And I can share with you the paper later if you ask me. I propose 4 categories into how we should reduce the complexity of seeing vehicle to grid. And when we are proposing a project and we're trying to evaluate if it's good or not, to try to be transparent into the assumptions of what information or what complexity we are controlling and which are not. Thank you. I will share it with you then. Thank you.
Okay, so you're getting input by Shell as a start. Other questions? Feel free, yes.
Hot topic, and whilst I kind of disagree on finding one framework because markets vary very significantly geographically, I guess the question is, does Stellantis believe that vehicle OEMs are best placed to generate and transfer value from V2X to consumers?
I can't talk for Stellantis, but I can talk sorry? I'm here talking as a researcher within Stellantis, but me personally, I believe, yes, OEMs should play an important role, and particularly who are closer to the customer, who is the owner of the electric vehicle. So I think that's an important avenue to explore future business models.
And of course, in the previous presentations, you saw, for example, Mr. Berg, an entrepreneur who can make money, and that's about making a profit. On the other hand, Lonneke Driessen, my colleague, grid operator, value is not only making a profit, so your costs added by a margin. For a grid operator, we have existing cables, and we have to manage those, and we have an increase of load of solar and vehicles, and by using that more efficiently, the societal value increases. So that's not money to make, but less spent for the consumers. Another question.
Hello, my name is Achim Friedland from Draft-Defined in Germany. And when you hear Germany, energy and billing, we are at the calibration law. So still today, the support of the German calibration law in 15.11.8 OCPP 2 is poor, let's say it like this. When we look into the car OEM world, it's even poorer. What is your way of supporting the very obvious thing of the German calibration law to bill for energy in the car OEM world? Do you implement it from day one, or do you still wait that others will implement and retrofit it for the German market? Because in the end, it's a very technical, useful thing, and not just a German special way of doing things. And I think sooner or later it will be a European calibration law.
So Europe must do as the Germans.
So the question is about what do I think about the standards of communication, basically. And if that's the question, then we can discuss it. But as I show we need sensors in the, to be smart, to create value, we need sensors in the equipment, and we need that these sensors are able to transmit the signals among different actors. And for that, standards of communication is a must. So which is the best standard to implement or not? In my point of view, would be that it's a standard that is able to be adaptable to exploring all these potential business cases and all these particularities that we might find from historic contexts in different settings, as in Germany or in France or in Spain. I don't know.
Yeah, thank you very much. And two other speakers might reflect on this question later on. In the next panel, there will be Terna, who has a vision on validation of the transaction between for frequency control. And well, if we all should do as the German Eichrecht, the calibration law, maybe a next speaker in this panel in a few minutes, Thomas Neuman from AVERE, can reflect a little bit on it. But thank you for the question. Other questions from the audience at this stage for Stellantis, or shall we go to Christiaan?
Then we can ask. Thank you, Diego, for your nice presentation.
I have to say, I think the slides are aligned for another speaker and not for myself. So maybe a difference in.
We can then change. Yeah, Thomas, please. So Thomas, you're not a representative of OEMs, huh? Thomas Neuman from AVERE. I let you introduce yourself and then presentation.
Perfect. Thank you very much. Good afternoon, everyone. Yeah, my name is Thomas Neumann from AVERE. I am policy manager for AVERE, which is a fancy word for lobbyist, slightly less loaded. First rule of lobbying in Brussels, no one does lobbying. So yeah, we do advocacy in Brussels for e-mobility. And yeah, I would actually need my, just here, I guess. Yes, and AVERE, less of a household name maybe than Stellantis. We're the European Association for Electromobility, which means that we advocate on Brussels level and across the EU together with our members for a regulatory environment that's favorable for the development of e-mobility, following the following high-level targets. Firstly, we want 100% new zero-emission vehicles, including HDV, by 2035 on European roads. Secondly, fully decarbonized road transport by 2050, and in the process, making Europe a world leader in e-mobility. Our membership is basically distributed around the entire continent, close to 60 members now. On the one hand, national associations such as the Formula E team from the Netherlands. On the other hand, also direct company members, OEMs like Tesla, for example, charging operators like Fastnet. Plus, via our association, we have indirect members, over 2,600 industry members and over 140,000 EV users across Europe as well that we represent, and on their behalf we advocate in Brussels. So smart and bidirectional charging is what I've been invited to talk about. I think you're all familiar, so I'll kind of skip through this slide. But obviously it offers a lot of advantages potentially for users. It can help reduce the cost for grid build-out because you don't need to kind of provide the capacity for all vehicles to charge at the same time at full capacity. It can offer economic advantages to users, kind of being rewarded for offering flexibility for their EV. And lastly, it can maximize the share of renewable energy in the grid. And how do we advocate for things like V2G? Well, we host events such as AEC, which will come to the Netherlands this year. I'll get to that later. But you're all invited. Then EVS, the Electric Vehicle Symposium, one of the biggest EV conferences in Europe, or in the world actually. It rotates globally. We engage, and that's kind of my job, directly with policymakers, European Parliament, European Council, Commission, Council of the EU. And then we also engage in projects, horizon projects, like, for example, Flow and Scale, which are two projects that kind of aim to test the scaling up and kind of provide insights on the scaling up of V2G, set up some pilots across Europe, etc., kind of making it work on the ground. And we can see that also in our membership, we have significant activities on V2G. Just two examples, obviously this test lab here, and also the activities in Utrecht with the pilot there that's kind of being supported or run by ELAD and the Formula E team. And secondly, we have, for example, Free2Move, one of our members that has a major pilot project in Turin in Italy, one of the biggest V2G pilots that's currently out there. So I've come to talk mainly about policies because obviously I'm a policy guy. My colleagues work on projects. So I will go into the files that you can see here. You see it's quite a busy policy agenda that we've been working on in recent months because the EU has a very comprehensive climate agenda and electrification of transport is really a priority in this context. So the ones I'll talk to are the ones that are most relevant to V2G, which is the Alternative Fuels Infrastructure Regulation. You might be familiar. We actually got a compromise at 1 a.m. tonight. So yeah, quite interesting. Energy Performance of Buildings Directive, which is the private charging equivalent. I'll briefly talk about Euro 7. Doesn't seem immediately pertinent, but I'll explain, which is emissions legislation. And then lastly, access to vehicle data. So in terms of enabling policies for V2G, firstly we have the Alternative Fuels Infrastructure Regulation, which sets the framework for the rollout of publicly accessible infrastructure across the EU, sets binding targets for member states about how much infrastructure there needs to be, and it also sets technical kind of standards for example, what kind of payments methods need to be offered, etc. And it offers, or it includes obligations on smart charging. Every publicly accessible charging point deployed in the future will have to be V1G capable, so capable of smart charging. V2G for the moment isn't mandated. We think actually that's a good balance because for the moment we've heard about the different kind of flows, data flows, etc., standardization protocols. There is still some scope for kind of market-driven development before we are at a stage where it should be mandatory and standardized across the EU. What we do have is regular evaluations by national authorities on whether V2G makes sense, how this can contribute to grid balancing, etc. So it's a good balance because it kind of moves member states to think about V2G without mandating it at this stage. Secondly, we have the Energy Taxation Directive. I'll run through this really quickly. It's basically setting a framework for taxation of energy in the EU. The one aspect here that's relevant for V2G is basically getting rid of double taxation. You often have the issue right now that if you charge energy into your car, give it back to the grid, then charge again, you're taxed every time you load energy into your car, which is obviously an obstacle to really monetizing and making use of the economic benefits of V2G. Through the Energy Taxation Directive, this might be removed. We're currently at the stage where the Council is a bit stuck because this is a very controversial file, more for things without or outside the scope of V2G, fossil fuel taxation, etc. But we hope it can move forward in the coming months. Then we have Euro 7. And Euro 7 doesn't seem immediately pertinent because it regulates emissions from vehicles. So it's about, for example, nitrogen emissions. But for some reason, and don't ask me why, the Commission works in mysterious ways, there is one provision in there that basically says that vehicles have to have devices communicating vehicle-generated data for the purposes of communicating with recharging infrastructure for enabling smart and bidirectional charging. So there's a data provision in there. Why the hell this isn't in the battery regulation, I don't know. For some reason, they've put it into Euro 7. So, it's a file that will go through the institutions in the coming months. It will actually be, again, a very controversial file. Let's see how long it takes because there are certain concerns, again, outside the scope of V2G about the compliance cost of making internal combustion engines cleaner, etc. It's going to be a very politically controversial file. It might take a while, but basically it contains this obligation to have the data available and accessible. And then, lastly, access to vehicle data. And this is less about the technical capability. This will really set the framework for kind of, or could set the framework for what kind of data needs to be shared, under which condition, with whom, etc. So the Commission has pledged to come forward with some proposal on access to vehicle data. And in recent months, it's vanished from the agenda and no one knows where it went. We see that there is a lot of polarization in Brussels. Aftermarket operators, charging infrastructure is lobbying for this to come and to be very strong, but OEMs don't like it. And you see the split kind of mirrored in the Commission, where basically parts of the Commission want to bring it forward and parts want to basically kill it. And so there's a bit of internal struggling going on whether this should come and how strong it should be. We still expect it to come, but we don't know what's going to be in it, but this will be quite crucial in setting further framework conditions about data sharing between different actors. So basically, to conclude, after this quick rundown, I think on infrastructure side, we see quite good regulations already. We see V1G mandates, so smart charging is coming. We see V2G regular evaluations. We see that in the EPBD for private infrastructure, it should already be deployed where appropriate, where national authorities see it. So a kind of top-up approach without too much regulation, but setting the enabling conditions and letting the market develop. On the vehicle side, it's still a bit thin. So we have the obligation to store the data and to be technically able to share it, but there's absolutely nothing on what kind of data needs to be made accessible, available, etc. And that's really where we see the main regulatory gap. We're working with our members to find a constructive way forward on that. Before I wrap up, I mentioned earlier AEC is coming to the Netherlands, our e-mobility conference in Utrecht on the 26th and 27th of September. So you're all invited to join us and discuss questions such as V2G, but generally infrastructure rollout, emission standards, raw materials, industrial policy, anything related to EVs. Thank you very much and looking forward to your questions.
Thank you. Very interesting topic, Thomas, here. And we can see that vehicle-to-grid, one of the main success factor is the communication between each and every actor. There is a cake to share, and how we will share it, and everyone should, gain here. The topic of data is a real topic from OEM who are responsible for their car, for their customers, to the service guys who want to provide vehicle-to-grid service, how we share. And these are the real interesting topics, that's not the topic of today, but, it is quite controversial, and it's normal that each and every, actor wants to protect its customers and its business. So, any question for Thomas on this?
Maybe starting with the previous question. Why isn't the German Eichrecht not in the European legislation?
Well, being German myself, Germans tend to have the perspective that their regulatory framework is the absolute best and all of Europe should follow. Not everyone tends to share that view in all cases. So there are some arguments about the significant compliance cost that the Eichrecht generates for charging infrastructure manufacturers, etc. It's quite strict measurement requirements. The question is if this kind of accuracy is actually needed, and it's a bit the worst nightmare of many operators that the Eichrecht might become the European standard, especially those that currently don't operate in Germany and don't need to comply yet. So let's see. There is a debate ongoing in Germany and in Brussels, and there is some push to make this the European model. But in the view of many of our members, it would be a bit premature, and in fact, maybe not the best model for the entirety of the European Union.
Yeah. So thank you very much. So calibration is good, but how tight the calibration should be a discussion between sectors and countries. Are there questions in the audience? Yes. Follow-up question or a new question? Yes.
Hello again. What is AVERE doing with the car-to-car communication people? Because there's also a lot of technology and a lot of use cases in car-to-car, car-to-traffic light, car-to-whatever. But this doesn't seem to be aligned with a car or with a vehicle-to-grid community, and also not with a vehicle-to-grid legislation. So, do you do something in this area? Do you try to combine these communities somehow? Because for me as a technical guy, it doesn't make sense that these are two people or two communities even using different technologies for communication.
So, I can speak to kind of my realm, which is the policy realm, and the short answer is no, we don't for the moment, because there's no ongoing kind of relevant policy files aiming to regulate car-to-car communication, where we do work on it, but I can't speak to the details. Well, at least two realms. A, we have obviously our events where we bring together industry actors, so we facilitate kind of B2B exchanges on that, less than kind of the institutional engagement, or more than the institutional engagement. And secondly, and again, I can't speak to many details there, but we are active in certain regulatory fora like UNECE, International Standardization Fora, where there is work ongoing on automated and connected vehicles, but this is led by my technical colleagues, so I can't speak to any details on what's being done on the technical side, since I'm the policy guy. So I can speak to my realm, saying that there is no upcoming pertinent union legislation that will regulate this in any detail, and so at least from my perspective, we don't address this in any depth for the moment.
Thank you. Yes.
Hi, Christoph from Electrico. So question, is there any standardization regarding the vehicle one grid or smart charging? Because right now, like every government has some idea you will need it, but no one says exactly if it will be the same or how it should be done.
The AFERE is not incredibly prescriptive on this, no. So basically it just prescribes that there has to be a capability to regulate the flow of electricity to the vehicle in real time, but it doesn't prescribe in much depth for the moment how this should be done.
Yeah. Other questions? Then I have one myself. We've been talking a lot today on the technical system and the regulation. Yesterday, the negotiation around the final version of the AFERE took place. And one of the new insights is that every charger should have a credit card device for payment. Will this work with bidirectional charging? Because then you have to get money back on your credit card. What is your vision on that? Has the Commission thought on this?
Okay. So, honestly, I don't know, and I think it's for market operators to find solutions and innovate. On first glance, I guess it would be more on kind of a subscription base with some kind of e-mobility service provider that you would be able to kind of get money back. In the case of ad hoc charging with card payment, hard for me right now to envision how that would combine with V2G, but if someone here has bright ideas, I'm very happy to discuss them and see how we can get them into regulation. There's one little inaccuracy, or potential inaccuracy. Basically, we are all completely in duck. We don't know yet. We don't have the final AFERE compromise. We just have some hints. The most likely outcome is that card payment will be mandatory for charging stations over 50 kilowatts or for fast chargers, and that for slow chargers you might be able to pay with QR code. But the communication is a bit cryptic. Everyone is scrambling on Twitter for some MEP tweeting information. We are waiting for the final text, so we'll have to do the full analysis. But yeah, how the ad hoc payment requirement that is coming will combine with V2G, difficult to say at this stage, if it's possible at all.
Yeah, so the policymakers have something to think about, the refunding on bidirectional charging. That was the reason I stated the question. Thank you very much. I think Yasmine.
Yeah, I think that please you can stay on the floor, and we give the floor to Christiaan.
Thank you.
From Hyundai.
Yes, thank you, Yasmine. Good afternoon. Nice to see all of you, and thank you also for ELAT hosting this event and asking us on stage to tell something about our V2X future. My name is Christiaan Pielkenrood. I'm a manager for new business and mobility for Hyundai Motor Netherlands, which is a full subsidiary of Hyundai Motor in Korea. The oldest subsidiary, by the way, in the world for Hyundai, good to know. But yeah, I like bold statements in my first slide, so I put up there Hyundai's leadership in electromobility because we feel this way, of course, we're proud about that. But also wanted to remark on the discussions I heard before in the room when other speakers were speaking. Sometimes the question was raised, but how does the OEM act on this? What is the role of the OEM in this part? And good that we have a voice here right now to say something about that. Because I truly feel it's not only up to us to bring that technology, but it's something we have to do together, of course. But how are we going to do this? And therefore, I would like to start with some basics from our side. So we have some history in EV. We started, I know it for the Netherlands, in 2016 with our first EV models, quite some various electrified drivetrains, and have been introducing EVs ever since. So we think that we are earning our stripes as we go along. Currently, we have something new that is also giving us more possibilities, which is the eGMP platform. And our eGMP platform is created for future customers and future demand. The future, you can see it and working already next to the stage. With this eGMP platform, I mean, we didn't design our Ioniq 5 and Ioniq 6 vehicles with the idea we start on design first and then we create a platform that is needed to combine with that. No, we started on building the platform first with the needs of our customers and built a design around that, so the other way around. I mean, eGMP's platform is giving us new possibilities of the way people are using that platform, not only in mobility going from one place to the other, but also in terms of energy transfer. And I think this is a great situation to build on and to eventually commercialize to our customers on that. Well, what is the main feature of this eGMP platform for us and for our customers? It's the 800-volt ultra-fast charging. I mean, with Hyundai, we can say that we are one of the first mainstream brands with models in mid-class sizes that we offer 800-volt charging instead of competitors. What does this 800-volt fast charging do? Probably you already know, but I'd just like to point it out, is that we can do quick charging or rapid charging really fast, DC charging. Up to 80% in 18 minutes at a station of minimal 300 kilowatt hours, and under 5 minutes we can add 100 kilometers of range to the total range of ours. So I think these are good base situation where we can create further advantage for our customers onto that. But this is, oh, you don't see it yet, it's the next point. This is the situation which we see the world in the future. We're talking about the V2X area in general. We already are making some steps within the V2G field, but of course also some features which are currently on the car, like vehicle to load, which was demonstrated before. I will say also something about that, is already applied to our vehicles. But yeah, please keep in mind that the whole world actually is putting their heads together to solve the environmental problems, such as greenhouse gas and also climate change. Countries are changing their energy infrastructure to accommodate the need of the people that are living there. And also the automotive industry is preparing this way by going from ICE petrol cars to more electrified drivetrains, and in particular battery electric vehicles. But it's causing some issues doing this. Hyundai Motor Group, too, is also focusing on promoting electrified drivetrains, specifically battery vehicles, electrified vehicles, that can provide and manage safety for their customers, but also gain an additional advantage. So this advantage, which I want to show first, we saw it in demonstration earlier, is the vehicle to load adaptation. Just quickly want to run by you some advantage on this. An apparatus of maximal 3600 watts can be attached, can be used. And what the fun thing is that we designed it in a way that we saw some use cases for it, but the customers really surprised us using that vehicle, using that feature in a whole different way. But why am I mentioning something about this? Because this is at least a V2X conference. It gives possibilities for a later moment, because due to the vehicle to L option that is applicable on this vehicle, we already have a bi-directional onboard charger that can transfer energy both ways. At least it's a major upgrade of the vehicle to load, a major upgrade versus the previous systems we had on our vehicles. But to go to the next step, according to a recent assessment by the European Environmental Agency, up to 80% of the vehicles in the EU will be fully electric by 2050. So this will take a huge pressure, of course, on the grid at that time. There will also be a rapid increase. Some markets will not be ready to do the transition. Some car manufacturers will not be ready to this transition, but it's a step that is necessary to do. And we believe that we have a solution for our customer at first, to use vehicle-to-grid or vehicle-to-X opportunities when they purchase a Hyundai vehicle, but we also feel the need for, we call it progress for humanity. It's our international motto, where we also see that we are not only selling vehicles that can do electric charging, but adding features like vehicle-to-grid, we can also add and give something back to the community to do so. I think it's quite clear how a vehicle-to-grid vehicle can support a renewable energy future, of course. And I think the vehicle-to-grid technology offers a huge potential. Storing that renewable energy in your vehicle, is it at your home, is it in the public environment, using it back to power up the grid later. I think you all also understand the necessity and importance of this technology. Our experience with V2G is quite large, I would like to say, is that we are already doing worldwide quite some projects with V2G. A lot of projects went on in Korea. We recently also in Europe finished a project in Germany where we had about 10 houses we connected to vehicle-to-grid vehicles where we could supply that energy to those houses and to the grid. Currently in the Netherlands, we're doing another huge project, and I think also Berg told something about this this morning. But we are really proud as Hyundai to be a part of the Cretaceous project, where we are delivering 25 vehicles which can do vehicle-to-grid. And by the way, those cars are almost the same as the ones that are coming off the factory line in its way. It's mainly software that there are some changes in. But we will offer 25 vehicles for this area, not with the number one reason to supply those areas with energy, of course, but to sustain it and to contribute to the grid and get those peak moments out of the way. Because there are cars that will be used as car sharing vehicles. They will not be full out the day present at that location. Probably the majority of vehicles will be present at those locations when there is no demand for energy at the nighttime. So we need to figure out how to be smart and how to use those vehicles in the best way to offer a solution also for the already busy grid in that area as well. But I think one of the reasons for Hyundai to start in the Netherlands is because the situation for testing is really that great. I mean, Netherlands, geographically small. We have a high adaptation of smart meters. We have a high adaptation of solar. And all these things make it very interesting to really start with a project like this and also do testing here in the Netherlands on a larger scale. And we use this testing not only to test out technology, because I can say from technology perspective, we as an OEM are ready for a bi-directional future. And I can state it that bold because of the testing we have already done. Also, there were some questions about AC or DC future in this context. I would say that we as an OEM didn't choose for a specific direction. We are exploring both, but currently the projects that we're doing are mainly AC. And I think also Oren explained in the morning why that reasoning is, because that local grid is simply AC to make it more efficient and also cost-wise. Replacing wall boxes at people's home in public spaces is in that sense also cheaper to do on AC, but both have their use case in specific areas. But we're happy to do that testing in the Netherlands for the reasons I just mentioned, and I think that this project will help us until the point that we start commercializing our V2G opportunities with our vehicles, and I think that that future would be more near than you could think at this moment. But for me, that's it. So thank you for your attention.
Question for Christiaan before we start the roundtable and discussion.
Yeah, we have Driivz. Yeah. 2 questions in one corner. Harm. You're in the way, Harm.
Hi, my name's Rowan. I'm from Lunar Energy. My question is, first of all, I was really interested to hear about kind of some of the projects that you're doing and the experiments, particularly the one with WeDrive earlier. And it sounds like there was a bit of back and forth where you had to kind of develop some software updates and stuff to get that to work. So my question is, once you feel like some of these experiments draw to a close and get to a final stage, where obviously it's possible with the hardware, is the plan to then actually go and run updates on your existing commercial vehicles and give that back to your existing customers?
Yeah, so as you're mentioning, completely right, we are in a testing phase, and therefore you always need to go back with different versions of software of the ISO 15118-20 we're using. We're not using the latest one on the specific car here. We're using one that we already used for tests earlier. So going back and forth, seeing what is working, that is something that always needs to be done through testing. I mean, I think that's understandable. I mean, we are targeting, of course, to have the latest version of ISO 15118-20 integrated on our vehicles when we commercialize V2G solutions. When this will be, of course, that will be decided later and communicated as well. But at the end, we're adding these features for our customers to give them the possibility to use it in their best way possible, right? And I think there, a customer can decide to choose for a Hyundai with V2G versus a competitor who doesn't have it, and can decide upon their own business case how to use it in the best way possible. And I didn't fully hear the question, but I hope to give you an answer in the correct way.
Yeah, mostly. It was just also about then when you feel like you are ready, when you feel like you've reached the stage where the experiment's over and stuff's done, whether you will actually go to your existing cars and basically update them. Or
yeah, retroactive, you mean updating everything. That's difficult. That's difficult because what we do see, what we couldn't see always is in an older vehicle what type of hardware was needed to have a V2G solution in the future, right? So although there could be a way technically to apply it, is it the best way for us to do so? Yes or no is the question. What I can say is that we're looking into possibilities on how to, for example, retroactively fit V2G for certain models that will not be commercialized with V2G at a later point. So we're looking into this. This is not a promise. What we really do feel, if you talk about scalability, you want to scale, if you want to bring something that is really representative to the table, activating also older vehicles into a V2G environment would have our preference, but not from the beginning. I mean, we're starting something in a world where a lot of people are starting just to be able to offer, and having all of that combined at one time might be too much. But we are looking into that for the older models. Yeah.
Yeah. So, Chan.
Hi everyone, HK from Luna Energy once again. So we have quite a lot of questions.
No problem.
So I think this is to address everyone, especially the two OEMs, car OEMs in the podium. So I guess the biggest question is that if we look at a lot of the V2G trials and all those things, the revenue typically goes to the customers. But at the same time, what happens with when you're exporting from your cars and everything else, there's a chance that, well, there's an arguable statement in the literature that it can degrade SOH and a bunch of different things. So now the thing is, if your customer is getting revenue at the expense of the car OEM losing SOH, which you cover it through your warranty, how is that going to work, right? That seems to be a bit counterintuitive for you guys to offer this sort of V2G capability, but at the same time you have to put in more warranties, or you have to, because people just take part in all V2G stuff. So what's your view on that?
This is in that sense an actual question we are debating also amongst ourselves, let's say. I mean, looking at the studies that are being done on battery degradation for vehicle to grid or bidirectional charging anyway, is in general that it sometimes can have a positive effect on the battery state of health. But it all depends on how exactly that business case is defined, what you're doing with it. Therefore, we are doing these real-life tests. As I said, we just closed one in Germany where we have supplied 10 houses with a bidirectional vehicle. Now we're going into, with the project with Driivz Solar, into V2G, so public discharging of energy. So we are using those various business cases to see what effect it has on our battery and go further from that. But we're not on that point that we can say anything about what does the battery do within our studies. We will come out on that at a certain point, but we're really looking into this. And I think you're right in saying that there's a business case for that customer using a vehicle-to-grid enabled vehicle that also has to think about any warranty that is pending on that battery. They can depend on themselves what to do in that situation, but we want to create a situation that for a customer when using V2G, there's of course always a benefit in that way. So it shouldn't be a negative using that situation in terms of scalability. So we will look for the customer in the right way to facilitate them with the technology, with that use case, and that also that we are covered in any way possible. So win-win for everybody.
Thank you very much. There's also on the stage Diego from Stellantis, but here is Pierre, and he's also from Stellantis, PhD, doing research on battery degradation and other things. Pierre, what would be your answer?
Hello, everyone. Yeah, so I'm interested a bit in battery degradation. And so I'm a bit dubitative that V2G can actually extend the lifetime of the battery compared to V1G, for example. However, there is a good way, I mean, good ways and bad ways to do V2G. The idea is, of course, for OEMs to optimize that for the same degradation to maximize what services you can give to the grid. How to manage with warranty and so on, that's a very difficult question. Well, for one thing, perhaps an idea is to also account for virtual mileage you can have with V2G in order that any V2G you do is accounted for in the battery warranty. Otherwise, just the OEM can also authorize or forbid the user to do V2G. That's a very, very harsh way to do it, but I mean, it's on the table if the warranty is in danger.
So battery degradation is taken very serious by multiple OEMs with research by PhDs. It's not a showstopper yet, but the clear answers aren't there yet as well. So we'll wait till Pierre graduates.
Maybe I can add something to this, is that also looking at the total, the bigger picture of V2G and what it can do, and for us as an OEM, the cost to develop this and to implement it on our vehicles. I mean, battery warranty is a big thing, which we need to look into a lot. Also going back to the previous question about adding it to previous models, also their battery warranty is one of the big items why that is difficult to implement a V2G on all the vehicles, I feel. But if you look to the total business case for V2G, I think technologically we are advanced. We are already having possibilities there. But looking at, of course, the business case where a customer can earn some money, there are some steps to be made in legislation and also fiscality parts of that legislation specifically. So, I mean, when a OEM wants to implement V2G on a vehicle, they need to be assured on certain things that are in place simply. Having such a feature turned on, once those things are not in place, makes it difficult for OEM because they're giving a customer something to use, but not knowing the correct way always. So I can only speak for OEM as ourselves, but I think that technically we were already there to start, for example, doing V2G. But all those things combining in the total business case, making it a good situation for all, is making it difficult. And there, we are applying in projects like Scale to finalize those protocols, finalize that legislation, and to discuss with all of the parties involved how to do this the best way.
Thank you very much.
Yeah, thank you. Maybe
round of applause again for Christiaan. And yeah, last presentation.
the floor to one of the long-term partners of ELAT, the back-end office provider, Driivz. Oren, floor is yours. Maybe this mic, so I can go for questions.
Hey everyone, nice to see such a big crowd attending an important conference that involve OCPP and V2G in the next few days. Driivz is a big, or would like to think that we're a big part of the success of the wide implementation of the OCPP. My topic is a bit off from what we have discussed so far, because I want to talk about security and how it is important for general OCPP communication, and specifically for communication between the charger and the backend system. And we can apply that to V2G, but also for V1G or for any other standard communication between the backend and the charger. So when we look at the ecosystem or the whole marketplace of generation all the way to the vehicle, we can see different use cases or vulnerabilities that can apply with these scenarios. On the left side, this is where the driver and the vehicle, especially when you have a charger, a public charger that has a card reader or any other way to, for payments, there is a big vulnerability of identity theft, of exposing personal data, etc. But that's standard. And in general, we would like to look at any charger as if it's a vending machine, basically, or IoT device with the ability for payment. And that is being neglected for a while, for many reasons which I will discuss later. So especially when you have payment, but not only, this is an initial access point for the whole system. Then especially when you look at fleet, it becoming a bigger vulnerability because you have a big business that depends on the vehicle. So if you damage through an attack a charger or a vehicle through access to the protocols, that becomes now revenue loss or mission that cannot be accomplished. And then the main thing, the important thing for us at least, or we think that that's the biggest vulnerability, that would be the actual charger, the OCPP communication. It could be, as I said, standard OCPP, it could be V1G, and it could be V2G later on. It is relatively easy, if you're not using the right measures, to pretend you are a charger and open a WebSocket to the backend. That can be handled if you apply the right measures, but in many cases we don't see those measures applied on all networks. So what we call an evil twin, basically the ability for me to open a WebSocket from my desktop at home, pretend I am a charger. That's not very hard to do if you don't protect your network. If we extend that to the microgrid, or it could be home, it could be a multi-dwelling unit, an office building, or a fleet depot, then you expose yourself to additional use cases. It could be a V2X fraud. You can discharge or request to discharge from a vehicle. And when we look all the way to the left on a grid level, that can become a real issue of a denial of service of the whole grid. Basically, if you don't just use one charger, but you pretend as if you are thousands of chargers, you can risk the integrity of the whole network. So how can that be, how can we handle that? So if we look at the standards, both OCPP 1.6 and OCPP 2.0.1 are not enforcing to use the security profiles that are embedded with 1.6 security extension and 201. But they do provide the measures to handle those risks. There are basically three ways or three profiles that you can use for communicating between the charger and the backend. The first one is basic authentication, basically using a WebSocket, not even a secured WebSocket, with username and password, allowing a charger to communicate with the backend. The second one is based on TLS, and that would be a secure WebSocket with basic authentication, username and password. And the third profile is a client-based certificate that is using a secure WebSocket plus a certificate, and that's, of course, the most secured way. Just as a guess, how many, or what's the percentage of chargers that are using one of those methods? From our experience, at least. Well, the lack of answering is actually representing the actual problem. Most chargers currently are not protected by any of these profiles, which is not very good. Why is that happened? Why does that happen? The first thing is lack of awareness. People think that if they use VPN or APN with cellular communication, that is secure enough. It is secure, but not enough. You can still find a lot of ways to get into these VPNs and pretend as if you're a charger or attack the chargers in other ways. So lack of awareness or thinking that VPN is good enough. Some of the chargers, many of the chargers, do not support all three profiles. And that means that even if the network operator wants to use one of these profiles, or at least the most secure one, he won't be able to because the firmware or the hardware does not support this. And as I said, wrong perception that VPN is secure enough. Then once it is understood, there's also the matter of cost, right? You need to maintain and install and all that. This does require some effort. It can be automated if the chargers support that, but there are ways. It requires some understanding that it's important enough. And I guess that's why we're here. What's our recommendation? The first thing is try not to use public internet for communication between the charger and the backend. It makes just the network more vulnerable. There are so many ways that you can very easily access it. Just in general, apply the most basic security layer and use APN. On top of the APN, there are ways, more ways to protect your network. You can provide, or the APN itself provides a limited access, which means that you don't need to allow SIM-to-SIM communication, just block this communication between the chargers. There's really no reason to allow device-to-device communication. The APN provides better monitoring, so every attempt to connect from an outside world will generate some kind of an alert. There is a really good way to at least quickly handle issues, and that would be to maintain a list of SIM to charger assignment. So even if the charger is compromised, you can at least identify this charger and remove it from a list, or link it to a new SIM. If you must provide public internet, which is in some cases not possible to avoid, you can at least maintain, use static IPs. Basically, this is like a poor way for creating a VPN. Maintain a list of IPs and only allow them to access your network, you can also map charger to an IP, which allows you to identify that there is no one to try to pretend as if they are another charger. Bottom line, use the advanced security profile. This is our recommendation. That's the OCA recommendation, which needs to be probably in the next version or so become a standard. Don't allow to use open communication. If possible, use client-side certificate. This is still very poorly handled by the charger manufacturers, but this should be a recommendation of the market. And if you can't use certificate, use at least basic authentication. Thank you.
Thank you very much.
Thank you, Oren. Please, you can please have a seat. And I would have a question just to you, Oren. We have heard AVERE talking about the new regulation and also the request that is put on OEMs to share their data. You talked a lot about this cybersecurity topic. Don't you think that it's not another breach to this cybersecurity? What's your reflection on that data exchange from OEMs and.
So when usually OEM looks at vulnerabilities, they look at connected cars, way to access the vehicle themselves. On our side, there is another access point, which are the chargers. So yes. The chargers needs to be protected, of course, on top of any direct communication with the vehicle. And any backend, the communication with the APIs of the back office, which basically is the same as accessing a charger, needs to be very well protected. So I can't speak on behalf of the OEMs. I know that they're doing all what's possible to protect the connected cars. There is a big industry around cyber communication with vehicles. It is less advanced, at least at this point, the ways or understanding that the chargers needs to be also protected.
Thank you. Thank you very much. I would like to ask a general question to you. We talk about V2G, but mostly from an OEM perspective, it's talking also about, first of all, bi-directionality of cars before providing service to the grid. And then once your car is bi-directional, whether AC or DC, then you have to provide the service to the grid. And then you have the car and you have the charging point. The question is, one question is, what is the certification process and how you as OEMs, what is your expectation first of all, and do you have a certification methodology or process, who you should certify? Is it a question to you or is it a question to the, someone in the audience, by the way, or is it a question that AVERE should take at the policy level and EU?
I would say that if we're talking about certification according to following a protocol or compliance with a standard, we need a procedure for all type of standards to have a reliable vehicle to grid. But we also have to think about how we can reduce the administrative costs and the burden of validating this certification against the grid operator or against different settings in which the electric vehicle will be connected, I would say.
So being part of the full team that within Hyundai is trying to achieve V2G or V2X possibilities. I'm not dedicated on certification, but I know some issues around this topic. And I mean, one of the questions that we actually posed to various parties from the beginning is, what do we need to certify? Is it our vehicle? Is it only the charging station that needs to be certified? Both, what is the necessity? And actually there was no one answer to that question. So I think the reasoning behind for OEMs to enter this V2X space is that that type of certification is decided upon. I can also understand that if you have no one offering that possibility, it's difficult to decide upon. So there's a chicken and egg story in there. But I think together with having more OEMs entering this space, having these scale projects, we can decide upon that together, and but somewhere we should simply start.
Yeah. Is it some topic that you're discussing at the AVERE or at the European Commission?
It's surely a relevant topic, and there is, for example, a Commission subgroup of the Sustainable Transport Forum, which is the STF subgroup on data, which is like the expert for that support that discuss data-related questions. We are part of these discussions. This specific question is, I don't think, currently kind of high on the agenda, because we're still talking more high level about the AFRY and kind of which data dimensions need to be shared there, etc. But it might be in the discussion going forward a general standardization approach that has been chosen under AFRY. We think is very smart. We said earlier in the kind of V2G space, there's still quite some scope for kind of market-driven, like B2B developments in general. And so for now, we have basically an annex that provides a list of things that the Commission wants to standardize in the future without really without putting anything in yet. But it kind of provides the structure. And if the Commission wants to then regulate it in the future, they can kind of fill this in. So that's in our view, kind of a smart standardization approach that kind of regulates as the market develops.
Okay, thank you. I think that this is one topic that is still a challenge, and there is work to do also for OEMs to know where to go and how to make it. Any questions? Yeah.
Yeah. Shell and Achim again. Here you go.
Thank you. Yeah, hello again, gentlemen. Thank you very much for the great presentation. We all talk about the problems regarding technology, and I think technical problems are not really problem, because if there's a problem, there's an engineer. That's what engineer does. So what wonders me the most is, so for V2X, there's a long value chain with a lot of players in it. And it's, to me, a quite granular way to manage all these moving batteries. So the question is, what is the incentives for OEMs to really dive into the V2G field? Thank you.
So if I speak for Hyundai and our purpose and our goal of achieving V2X possibilities for our customers is simply twofold, in my opinion, is that we create a use case for our customers that we are the preferred brand over other brands who do not offer it, right? So that's the first start, or why to offer V2G anyhow. And that there's a business case for them to when they need to invest in that technology, that they will have a method of also earning back that investment. Secondly, I would say that within V2X, I mean, there's something which is a social responsibility there, right? I mean, we as a car OEM, as I said it in my presentation, is that we are producing a lot of battery electric vehicles. Also, we do hydrogen electric vehicles, but of course, with battery electric vehicles, there's a dependency of the grid and how good it is. And we need to scale up, because future legislation will make sure that we'll go the electric route, let's say. So to be able to cope with that growth, we also offer our customers the usage of their vehicle as a V2G car. So predominantly it's concerning our customers, and secondly then also in that sense giving a little bit back to the grid, not only using it for charging, but also able to stabilize it because our customers are using it way to power them for themselves. And this applies for the vehicle-to-home situation, and also really for true public V2G in that sense. But I think for us, those are the two main incentives.
Just to complement, several car manufacturers, and including Stellantis, have ambitious climate change targets. Particularly, Stellantis is a 50% reduction in our scope 3, which includes what is the indirect use of the electric vehicles. So it's in our interest to provide also with our customers, a possibility of contributing to the decarbonization of the electric grid.
Okay, thank you very much. Here's another question by Achim Friedland.
I have seen your security analysis, but when I look closely at it, you're totally missing again internal attackers. So as a German, I would say, even if you don't like the German calibration law, the German calibration law is the only technological solution to address also internal attackers. And did I really understand you correctly that 4 people had been basically telling us, please regulate us because we are not able to provide a solution on our own? Is this really true? Because then I know what I have to do.
I think at least the question that I'm posing about regulation can be interpreted in various methods, let's say. So for me, one of the things where regulation is needed for is in terms of fiscality here in the Netherlands. If somebody uses the power of its employer and uses it to charge their own home with that electricity, how does it work if you have to pay for that energy? Do you pay double the VAT? These type of questions need to be solved, and therefore legislation is also necessary. So I don't know exactly, I mean, I work for the subsidiary in the Netherlands in that sense. I don't truly know the situation in Germany, but when applying a V2G solution, we will apply it at the end for Europe. But having all of these markets with their own rules, their own situation, does make it difficult for OEM to start with V2G services in Europe, for example, because of that different situation everywhere. And I pointed out that we like to do projects here in the Netherlands because of that situation of smart meters, solar panels available, high effective charging grid. But those are necessary to do so. So we will look to other markets to operate in, we will assess the local situation, and it could differ a little bit than what we are doing in another market. So we need to see market by market how we do implement it, because everywhere there's almost a different situation needed, it seems like.
I think
it's
there
not
is a
really
harmonization needed more than, I mean, the harmonization among European countries are necessary. I guess this is important for you, and also in grid code, in basic rules and regulations, so that you can go everywhere and not starting all over again.
Correct.
So this is the harmonization that is necessary. And from a regulation perspective, I can say a word, but you mention it.
Yeah, I think the good thing for everyone, this session is recorded. So especially for you, Achim, the answer of Thomas in the previous question, harmonization is important. Do that by collaboration and not just implement German rules. How good Germany always is, but optimize and listen to each other. I think that was your remark, Tom, for being a German.
Yeah.
Other questions before we head for a tea break? Patrick, last question.
There were another one as well. Go ahead.
Okay, so Patrick Rademakers, I'm from Shell. Shell has curious peoples. If I were to look at a charger as a...
little bit closer.
So if I were to look at a charger as a barrel of water and the faucet is the OSPP connection, we are very much worried about the cybersecurity of that faucet. But we are not checking the barrel to see if there are any other holes. Any or almost all charge points have a manufacturer backdoor via Telnet, SSH or something else. There's no standardization there. Nobody seems to really be concerned. Some manufacturers even have their own SIM card, additional SIM card in there. So there are plenty of holes in the barrel, and we're very much focused on just the faucet, the one part that is standardized. So what's your opinion about that?
I would agree with you. These are backdoors. They're not well protected or verified. That I don't think anyone is actually regulating those backdoors. The charger manufacturers protect those because for them those are added value services that they add on top of OCPP. I think the better OCPP will become, the less need everyone will have for those backdoors. But if it can be regulated, then of course it should. We call for standard communication, and the OCA is very strong to promote it, but they don't overcharge those specific communication. I would agree.
Okay, thank you. Two last questions here. Who are you?
My name is Jared Newell from the Mobility House. I have a question. We've talked about costs in the OEM in regards to V2X, and we've talked about the cost, the benefits for the end user in being able to charge and discharge and get benefits from the grid. My question would be: what is the discussion around the cost of the end of life of the battery? Is this being taken into account?
I would say, of course. I think your colleague said something about virtual mileage in that way, and these are new things that we need to see how to manage that, and just simply one of the difficulties for an OEM how to counter this. I can also say that we're busy working on that solution for now, so a direction, something I simply cannot give right now, but looking at cost for OEM, I think the warranty part about the battery that they are supplying is one of the biggest topics that is on the table for implementing V2X services.
I'm not fully knowledgeable on the subject, but I'm following closely the regulation on critical resources such as lithium. And I think the value will come by itself thanks to these regulations. The thing is to observe which is the best regulation given the setting in which we are, but I think that's another conference in a way.
Okay, thank you. Last question.
Hi, I'm Denita from Ampeco. Thank you for your presentations. I would like to ask you, do you see the V2X as a thing that it will replace the demand response and the dynamic load management in terms of users and decisions by clients? Thank you.
I think it's just another tool in the demand response overall tools that the DSO or the TSO can apply. So if you need to do congestion management or to do or to apply other tools in the system to manage demand response, V2G becomes one of them, already becomes one of them. There are first ways to reduce charging, but then if you reverse charging, it increases the value. So for us, it's another tools in the toolbox.
Okay, thank you very much. Yasmine, I think it's tea time.
It is tea time, yes. Thank you very much, gentlemen.
Everybody is seated. Thank you very much. We would like to continue. Okay, yes. Thank you very much. Last part of this day regarding standardization, standards and protocols. So we're delighted to have some major players. First kicking off with Tomoko. Welcome from CHAdeMO. Floor is yours. You want a microphone? Yes.
I'm coming over here, but hello everyone. Thank you so much for the kind introduction. I'm Tomoko Blesch, representing CHAdeMO Association in Europe. I'm based in Paris. Really delighted to be here. All right. What's CHAdeMO? I presume that everyone knows what CHAdeMO is, so I go super quick. Our mission is to bring safe, affordable, and interoperable charging to EV drivers. Established in 2010, We are a platform of collaboration. Our plug shape is the same wherever you go. And we have an impartial third-party certification system for the charger side, for now, already set up. Because for us, safety and interoperability is super important. Why am I here today? Because today we are the only EV charging V2G standard with a decade of real in-market experience. The first CHAdeMO V2G products came to the market in 2012, and then CHAdeMO wrote the protocol for V2G in 2014. For CCS, of course, the bi-directional charging is now possible with 15.11a-20, but from our humble experience, it took us 4 to 5 years from the protocol publication until it got stabilized after real market validation and debugging. And that is just EV and EVSE communication. There are multiple layers of communication in the back end and a couple of layers up and to the energy market side. So there's a lot more work ongoing by a lot of you in the room, I imagine. Another difficulty is certification. That has been the topic of the last panel. For example, here's the certification that we have in Japan. CHAdeMO partners with 11 certification bodies in 9 countries. And these accredited organizations can have and have performed CHAdeMO V2X certification in Asia, Europe, and North America. CHAdeMO V2X certification, that is between the charger and the EVSE with the dark green dotted part, is defined by CHAdeMO. And the certification for communication between the charger and the building to the grid, that can be typically prepared by industrial organizations like EE-Bus for the case of Germany. And from the charger to the grid, that's the orange line. Those are the electrical requirements certified by protective relays, people who certify protective relays for grid connections, such as solar PCS, fuel cells, and cogeneration systems. This setup and requirements can be quite different by market and can take a long time to obtain, but CHAdeMO V2G charging has already succeeded in obtaining certification in various countries in Europe. For example, in France, most recently, we were certified to be able to provide the most demanding grid services by the Transmission System Operator, RTE, to perform FCR. Since the publication of our certification criteria, that was in 2015, we have 40 V2G products already certified from 19 manufacturers. With more products come more projects, as shown on this map. We understand that there are some 120 demonstration projects in the world, so this is only a small subset of what we have seen. Today, given the limited time, I will speak about 2 of the more recent projects. The first project is e-Velocity project from the UK. This project looked at the potential of V2G in real-life commercial setting using 15 V2G charge points across the UK. Of the key findings, I will just pick one point about battery degradation. That's the big question that we always ask. Their study shows that with the right charging strategies, the life of EV batteries can be extended by 8 to 12% at the end of year 1. I don't explain the graph, but according to the University of Warwick, who assessed the evolution of battery capacity fade under various scenarios, different use cases and charging strategies, with an intelligent balance between cycling and calendar aging, and with the right state of charge, it is possible to mitigate the total aging process from 7 to 26% for the first 100 days of operation, and then eventually 8 to 12% for 1 year continual operation. And that's depending on the driving profile, that's intensive driving, who drives a lot, or gentle driving, who people who drive less. So for more information, please do visit the website that is marked at the bottom of the page, or you can also watch the webinar that we hosted with the guys who actually did that research. You can find that on our website. Second project is the Power Loop project, also from the UK, but for residential application. For this one, 135 people were recruited, to whom a bundle of V2G services was offered, which included an EV, a V2G charger installed at home, and 2 applications. One to configure the V2G charger, and the other to manage intelligent V2X. The final survey yielded a number of findings, but I just talk about the technical issue that they found. First, many problems were due to poor internet connectivity between the V2G system and their home. Use of reliable and high-speed internet connections such as Ethernet was thus recommended by the team between the charger and home instead of Wi-Fi. The second one is the use of 2 apps made the system overly complicated to users and led to confusion. Multiple interfaces increase the possibility of failure and decrease the chance of diagnosis. So a one-app solution can be a good option for both customers and operators. Finally, a couple of points about CHAdeMO and secure communication. Here's the EV chargers and flexible aggregation and the communication between in a super simple way. And here's CHAdeMO defining EV and charger communication. CHAdeMO is designed to be the minimalist and flexible on purpose. And this is to avoid becoming obsolete. CHAdeMO remains and will remain cutting edge because we ensure compatibility with the adjacent technologies that are the latest versions. For example, we are of course going to be, and we are compatible with the latest OCPP. As an example, we work with the OCA guys to publish a white paper facilitating the implementation of CHAdeMO with OCPP. Now, with the eventual need for secure communication for more advanced services, some stakeholders propose to use 15.11.8 via PLC communication. For CHAdeMO, because our CAN communication is not encrypted, our proposal has been to use other possible secured communication options that exist already, including a cloud server via Wi-Fi or OEM telematics. But then again, we are also making ourselves adaptable in the ISO 15118-20 based ecosystem. CHAdeMO can apply ISO 15118-20 by replacing the PLC communication with secure Wi-Fi communication, defined in ISO 15118. This is being proposed in the edition 2 work of -20, with a common specification for CCS and AC conductive charging. And for your information, for next generation CHAoG communication, we will support both Wi-Fi and Ethernet. So for CHAoG, we shall be proposing to revise -1 for new use cases for CHAoG, incorporating CHAoG in that -20 edition 3 work. As a summary, CHAdeMO and its members have a decade of in-market experience of V2G with its certification system, and we're happy to share our knowledge and learnings. CHAdeMO's limited scope to the minimum for greater flexibility, and thus remains cutting edge in collaboration with the latest adjacent technologies. There are many ways to secure communication, and CHAdeMO proposes to keep the physical layer options open for future innovations. And we are all for collaboration, inclusive approaches to achieve our climate goals together. And that's AC, CCS, or CHAdeMO doing V2G. Thank you.
Thank you very much.
Please take.
Are there questions in the audience? Any questions on CHAdeMO? Yes, Mark Moulton.
Hi there, Mark from Switch. I'm a bit confused after this presentation. So you say you apply CHAdeMO via 15.11.8. Are you suggesting using 15.11.8-20 messages in the CHAdeMO protocol via Wi-Fi?
Correct.
Why?
You mean the charging control?
I mean, I don't know the CHAdeMO protocol that well, to be honest. But it is its own protocol via CAN. 15.11.8 is a different protocol with different messages. So what do you transport via CAN and what via CHAdeMO? What remains in CHAdeMO? I didn't fully understand this yet.
So what we try to do is, because we don't have the PLC wire line or communication line, we try to do this, what needs to be encrypted via Wi-Fi. So are you saying that this was not clear?
I think the topic was about the physical layer only, if I understand well, but I'm not a specialist. So, yeah.
Additional question?
Maybe, yeah.
I understood the physical layer part, that you want to use Wi-Fi and thereby ISO 15.11.8-8, that I got. But the content of what you want to send, that is unclear to me. Is it ISO 15.11.8-20 or is it CHAdeMO messages and data structures?
Good point. I think we're going towards the 15.11-20 messages, set of messages, but then I don't know the details, so I'd be happy to come back to you.
Yeah, I think the whole setup of this conference is not to provide all answers, because there are no answers on many topics, but to engage a discussion such as this. How does it work? And could you bring me in contact with CHAdeMO developers? Because there's a lot to be done on bidirectional charging. You've seen it, Korean vehicle, Korean charging station, but it must be extended with multiple brands, multiple ways of communication, and this might also be a topic for deeper discussion. So follow-up question, and we'll bring you in contact with Tomoko. Thank you. Maybe now then.
Yeah, first of all, I wanted to thank Tomoko for sharing experience, because there was some question this morning about the battery aging. And you had done some studies, I understand, and you can even show that depending on the state of charge and depending on probably temperature, depending on the use cases, you can even improve the state of health of batteries for such and such a percentage. My question to you, if you have the information, is what was the feedback from the end user, from the drivers? Did you have the opportunity in those projects to get those kind of feedback?
We, as CHAdeMO, are not the operators or the leaders of the project. So those are the people who have done the project via the Innovate UK funding scheme. But I think I've read for the second project where the people suffered a lot from the technical issues. They talked about the motivation of the end users. In fact, initially, their primary motive is like financial reward. And then towards the end, it became that the environmental end will become very important, or as important as the financial reward, which was very interesting.
That is quite
But then again, I didn't mention it, but the cost, a high cost of implementing V2G remains an issue. Not only the hardware cost, but like this morning, the California report also indicated that there were many more other things that need to be paid.
The investment and the installation cost, that was also a point for system operator, distribution system operator. But for now, thank you very much. I think that the time is limited, so probably we have the next presenter. There is there is the presentation of Terna here.
Oh,
thank you.
Shall we do Terna? Yeah.
But we can,
Let's be flexible.
Let's be flexible, yeah.
Yeah, Terna is part of a collaboration of European TSOs called AFRY. And within the AFRY platform, there is a collaboration on the Skill project, a project run by ELA together with Polestar, Hyundai, Renault, and multiple other organizations to unlock not only the load management of electric vehicles, but also the frequency control. But you're also active in another European project, Flow, and you operate your own test lab.
Yes, we do.
Tell us more.
Okay, thank you, Baerte, for the introduction. Pleased to meet all of you. My name is Antonio Bonvento. I'm from Terna. Specifically, I'm from the innovation department of Terna. And today I've been asked to bring you maybe the perspective of the TSO on e-mobility. So I think most of you already know what a TSO, so a transmission system operator, does for a living. But allow me to give my opinion on what we do for a job. So I like to think our work divided in two different tasks. The first one is hardware related, and allow me to say a bit more boring. So we basically build the infrastructure, the power grid lines, we run some maintenance, we need to be sure that it's working, of course, and that's the hardware part of our job. But then there's also another more interesting, at least according to my opinion, part of the job, which is software related. So we need to balance the grid and to keep it stable. And this is called dispatchment or dispatching of the electricity grid. And to keep the grid stable, basically what we do is we need to keep the balance between supply and demand in every moment of the day. Even now, I mean, here is probably the job of TenneT, but if you go to Italy, even now, we are balancing the grid. To do so, traditionally, what we've been doing is follow the demand. So we were predicting how much the demand was, and we were asking the supply to follow the demand, because that was the only way to keep the balance between the electricity system. But if we move on to scenarios, the scenarios itself, they're changing. So if we look at the first column on the left, basically there's a focus on how electricity production has been produced in Italy. allow me to walk through some of the key numbers of the table. So basically 1/3 of the electricity production in Italy comes from renewable energies. And that was, 2 years ago, but it's still kind of the same. And in 2030, the amount of renewable energy produced in Italy will more than double. So it's going to be more than 2 times what it is today. So we're going to move from 1/3 to 2/3. And that's going to increase the difficulty on managing the grid, because you can always ask a power plant to burn more gas or less gas to follow the demand. But believe me, it's quite difficult to ask the sun to shine a bit less or the wind to blow a bit more. So you cannot really balance the grid with renewable energies. So what you can do is install storages. And I think in 2030, our estimations are that we're going to have around 100 gigawatt hours of energy coming from storages. But what you can also do is use the help of the demand, actually, because nowadays the demand is getting smarter and smarter. We've been talking about this for the entire, for today, basically. So you could also ask the EVs, for instance, to charge a bit less or a bit more whenever the grid needs it the most. So I believe that's why I'm talking to you today. So I said we are expecting like 100 gigawatt hours of energy from storages. But I don't want to get any OEM angry, but for the system operator perspective, EVs are kind of batteries with wheels. So there's, at least in Italy, in 2030, we're going to estimate that around plus 10 million EVs are going to be running across the nation. And that means, roughly speaking, 400 gigawatt hours of energy. So there's a huge potential to use those batteries to support the grid when it needs the most. And there's actually someone who's already doing it in Italy. This is good publicity, so I'm happy to say it. But there's a plant from Stellantis located in the northern part of Italy, which is actually providing already 25 megawatt of active power from a V2G plant. So they have some vehicles on their own fleet. And while they're parked and waiting to be shipped, they provide service to the grid, and they're making money on it. So there's a new possibility for revenue streams from the OEMs. Apart from that example, try to be very brief, but I think this is now a good moment for TSOs, DSOs, of course, and OEMs to start speaking and working together. As Terna, we are actually part of many different projects. There was Equici, cited from Baerte just a while ago. It's a joint venture between TSOs that has the aim to help distributed energy resources, so small assets that are now connecting to the grid to provide flexibility services to the grid. Now is a moment where many TSOs and Terna as well, we are reviewing the grid codes. So we are asking ourselves, should we change something? Should we change the way we manage the grid today? Probably the answer is yes, but unfortunately we know we have to change something. We're still not sure about what's best to be changed. We're part of many European projects that focus on distributed energy resources. One is Flow, has been nominated maybe twice today, but there is also Be Flexible, which is another European project that focuses on how should we coordinate with DSOs when using distributed energy resources to provide support to the grid. So why is that? It's because we are using assets that are connected to the grid of the DSO to provide services to the TSO. So we don't want to create any congestion to the DSO grid whenever we're calling upon those assets. And then, last but not least, there is the energy system innovation, which I think I'm going to take a couple of extra minutes to speak about this, because that is a project I've been working quite a lot on the last few months. And I think this morning there was a call for action for TSOs, for grid operators. Well, here's one. So we what we do is, at least in Italy, the market is already open for participation from distributed energy resources. E-mobility is one of them, but in reality, there is not really a big participation of EVs and theirs in general to the market. And we feel it's maybe there's something still missing. Probably is the business model. So there's the money value cake is too tight, maybe for the actors at the moment. But but we also think there are still some technological issues that need to be addressed, at least. One of being the communication protocols. We've been talking a lot about this, and we want to help the OEMs to get the perspective of the system operator, to do it right, to do it once, to allow the technology, to foster the technology evolution once it's being deployed, to be grid ready and matching the requirements from the grid operators. And I think it's a good opportunity for us as well to understand a bit more on how EVs work. So the way to go for Terna was to go on 2 layers. The first one is focusing on single resources. So the ESI, that's the Italian pronunciation of the Energy System Innovation Program. Firstly, focusing on single technologies. So the most promising, we felt it was e-mobility. Maybe it was closer to the market. We want to test together with the OEMs, understand how EVs and VSE work, what they can do to provide flexibility to the grid, maybe what's missing, how we can help them understand what it means to join the energy markets. But then at the end, the TSO, and I think also the DSO will never talk directly to the EV, to the single EV and the single EVSE. We will always go through aggregators. So that's why we think probably in 2024, so next year, there will be another pilot project where we want to test together with OEMs and see maybe what's still missing from the picture that is avoiding distributed energy resources to join the electricity market. So the first energy system innovation project is going to be focused on e-mobility. I think I already kind of said a bit of what we do, why we do, maybe not how we do, but nevertheless, we want to make our hands dirty, basically. So the time for studies on paper, I think it's over. I think we all understood the huge potential there is in e-mobility, but I think allow me to say, coming from the innovation department, I also need data to convince my colleagues from the dispatching unit that these things actually work. So we need to provide sustainable and data, so we need to test them. We want to do that together with the OEMs, because we really feel there's added value on doing that together, collaborating, because there's also like a need to have some knowledge sharing. Like I don't know so much about how the EV works. I know more how the electricity system works, but that's, I would say, the opposite for OEMs, because their business is making cars, is making EVSE. That's right. Their business is not managing the grid. So maybe us system operator can help them getting a better picture of the system. And how we do it? Well, actually, we also have built our own testing laboratory, which I'm gonna show you. It's, I would say, it's younger than the one we have here at ILAD. So it's been commissioned just in August of the last year. It's located in the northern part of Italy, in Turin, and so he has 13 testing spots. It's kind of open for every technologies, because really, once again, we feel like being the system operator, we have to be a third party, so there's opportunity for every technology solution, being it V1G, V2G, prototype, commercial product, it doesn't matter, as long as there's value we both see, so the system operator and the OEMs. And the power range is quite a bit. We can connect assets from 25 kilowatts, maybe for domestic use cases, but even up to 500 kilowatt active power. I know that maybe DC fast charging have less opportunity for flexibility, to provide flexibility to the system, but who knows? We wanted the lab to be future-proof, so we increased the connection level up to 500 kilowatts, and even DC fast charging solutions are welcome to join the lab. Of course, it's free of charge because we really want to work together with the OEMs. It also helps us to address the market changes and to maybe, if needed, change the grid codes, because maybe the grid code today is not really fit for distributed energy resources, but we really need to know what's missing and how we should address it in the best way. So going towards the end, I just wanted to give you a look on what we do. So we also have defined different types of tests. So the first one, the focus on communication and connections, basically. Whenever there's an asset that comes to the lab, we install it together with the OEMs, and we check that everything is speaking the right language, so what messages are sent, are received. Maybe it also helps us get a view on what's really said between the EV, the VSE, and the backend. Maybe we can also provide some support and suggest some integration on messages that should be included. Then there are type 1 and 2 tests. To generalize, those are the tests we run to have a kind of a identikit of the EV and a VSE. So we really need to know what's the maximum power the EV or the VSE can charge, for how long? Is the power stable, or does it change with the state of charge, for example? And sometimes it does. So what's the efficiency? What's the activation time if I send a set point? So if from our backend I'm going to send a power set point, how much time does the EV and the VSE need? They both need to ramp up to that set point, and this is really helpful for us because to provide flexibility to the grid, we have requirements, and most of the requirements are translated in terms of minimum activation power, minimum accuracy, and that's what we're trying to figure out. And lastly, there are type 3 tests. This is a topic I think today has been cited quite a lot. It's battery aging. We included these tests mostly for the OEMs specifically. Like, to be honest, the system operator probably doesn't care how much the aging is for the batteries, but the OEMs and the final user, they do. And if they don't allow the car to provide flexibility service, because then the battery aging is too much, then the system operator cares. So what we do is we send the very same power set points we ask now to the power plants, to the thermoelectric power plants, and we do it for weeks, for months, to the vehicle, and then we check if the state of health of the battery changed, and if so, maybe how much, or how we can adjust it, maybe together with the OEMs. So to finish, the e-mobility lab, so our own laboratory, is already opened. The ESI e-mobility project is live as of December 2022. So every OEMs that wants to make their hands dirty together with us, with the system operator, are more than welcome to come and join. Maybe just work together, to have a better understanding of the technology. And if for those of you that are wondering, right, but what's the effort? I said it's totally free because we do it for the system, we do it for the entire EU. And there's also no, we have our own guys there at the lab running the tests. So for every OEMs standing there, there's no need to send one of your guys to the lab running the test with us. Of course, they are more than welcomed. We will be pleased to welcome them, but it's not mandatory, so you don't have to be. And yes, I think that's pretty much it. Yeah.
Thank you very much, Antonio. Antonio, I think that the last time I drove a battery on wheel, it was 6 years ago. That was called Autoleap. Please. These are nice and cars with fun to drive. I mean, this is beautiful things. Huh? There are people designing that. But more seriously, thank you very much for the perspective on TSO side. And you see that TSO, DSOs have to work together to make it work. Question on the audience, or yes?
2 questions.
Hello, I'm Alex from Monta. We have seen already some countries that have lowered a bit the requirements from TSO level so that smaller assets like fleets of charge points can join the flexibility markets or the balancing markets. I'm sure you can only speak for Italy, not other countries, but do you see this going forward as well? In the Scandinavian or the UK country, they have lowered the minimum amount of power required, or also the response times are varying now in the UK. Do you see Italy doing something similar?
Does it work now? Yeah. Thank you for your question. Well, yes, I can speak for Terna, I can speak for Italy. I know that every TSO has their own requirements. They're kind of similar, and they also depends on the type of services you are providing. I think there was a question before, maybe in the morning or in the afternoon, I don't remember. It was asked, is it better for EVs to provide fast services or slower services? Well, that also really changes the requirements. If you are providing fast response services, those are services where the grid really needs those on time, perfectly with almost 100% accuracy, because they are the first aid that the grid has and receives. But for slower services, the requirements can be a bit less strict. If I can give you my opinion, then I don't think here now to have a massive adoption of distributed energy resources. The real constraints are on times and on accuracy, because, I mean, they actually do work, and I do believe it. The thing is that we have a very deterministic approach, being the TSO, and especially my colleagues from the dispatching unit. They want to see everything. They want to know what the EVSE and the V, what they do, how much power has been absorbed or injected to the grid. And this usually is done by hardware installation, and they cost a lot. So if you want to have flexibility from many assets through an aggregator, it's kind of, money-wise, it's difficult to ask the aggregator to install a specific asset to maintain a certain quality of the measurements for every asset they aggregate, because, it just costs too much. So I think, yeah, maybe we could move into a stochastic approach of the measurements, but we need practical results. So,
thank you very much. Please take a seat. We're a little bit out of time, but fortunately Glenn is a very good speaker. Go ahead.
It's on.
Glenn
Thank you.
from Caron, welcome and applause.
Thank you very much, everyone. Thank you. I don't know if I'm a good speaker, but I'll try my best. Thank you very much. So I'm Glenn Cezanne. I'm Head of Public Affairs EU for Caron. So my knowledge is more at the political level, but also connecting your knowledge, engineering knowledge, let's say everything that essentially makes up the ecosystem from its backbone, and transferring it to the European institutions so that they know what they need to do. So in essence, Thomas Neuman from AVERE, who I don't see in the crowd anymore. I think he's on the call with an assistant from the European Parliament, because we just had AFRY passed, as he mentioned. We coordinated a little bit for today's discussion, simply because we didn't want to, repeat the same things, but give you a little bit of a different context. I mean, we shared half the trip over here, and we even laughed about who would say that I told him everything that he knew, but you know, one of the main advantages finally of not being the first one to speak. Anyway, so what I'd like to do today is, I put a presentation together, but frankly, after listening to some of the speakers and some of the discussion points, I'm going to change a little bit. The discussion points I wanted to provide is about the regulatory surrounding, but then also go into how we're working with protocols and standards with the European Commission, how we're working on plug and charge elements, PKIs, so on and so forth, and then of course, you know, advertise a little bit our own plug and charge Europe project and MCS. But I understand that the slides will be shared, so I won't spend too much time on them. Instead, I'm going to start with a little bit of the political context that I've been noticing more and more in my last 2 years at Caron. I only started 2 years ago at Caron, just as a side note. And the thing is, when we're looking at how government perceives us, there are essentially 2 points. And I'm going to start here with a little bit of bad news and a kind of a push for everyone to understand that you have an absolute major role to play to help political and legislative decision makers that provide the regulation to not over-regulate you, essentially. And here the point is that government looks at industry from 2 perspectives. First of all, they see industry and the consumer detached. Meaning that industry, according to the way government decision makers are working at the moment, is not working in the favor of the consumer. Industry is looking to profit, industry is looking to essentially bring forward its own products without consideration for the consumer, which is absolutely wrong. I mean, at the end of the day, this is a completely new ecosystem that we're putting forward when we look at e-mobility from every side of the planet. And this is one of my main jobs to kind of dispel that. The second part is, and this you notice when I'm going to go to AFRY, and I'll tell you why I'm going to go to AFRY for 2 reasons. But the second part is that we are seen very often as an industry that is trying to inhibit very much the rollout of e-mobility. I know very many actors here are pure e-mobility actors, there are others that are not. And very often they're mixed and put together, and also what happens is that there is that level of distrust coming from government. I won't focus on one spectrum of the government compared to others. You will probably figure it out for yourself. It's there, and you will see that certain leaning sides of government will focus more on that being an issue. That's the other job of mine, to dispel that part as a major approach. Now, how I've seen this happening is if we look at AFER. And this is the Alternative Fuel Infrastructure Regulation, something that Thomas spoke about before. And here at the moment, as he mentioned last night, they came to a decision, actually should be the 28th of March, because it was at 1 o'clock, depends on what side of the planet you're on. But we're trying to piece together what has been decided in the trilogues, which means that it's not been confirmed, but we are looking here at various very big issues. Targets, card payment obligations, retrofit, payment display, definition of smart charging, and so on and so forth. These are all elements as Caron that we've been focusing on, or as AVERE, just to, if I'm allowed to speak on their behalf, briefly. Now, AFER became a regulation, meaning that every single member state has to follow that regulation. They cannot interpret it, they cannot transpose it with other words, it has to be put into force the way it is. The predecessor was AFID, a directive, which meant there are certain rules that you have to follow, you can interpret it into your own law. And we are finding ourselves being driven by government, which is very unusual because what usually happens in the world of regulation versus technology, and of course it's not an exception necessarily, but exceptions do sometimes go from the rules, but what usually happens is technology advances and regulation adapts, or sometimes inhibits technology's advancement and so on and so forth. What's happening right now is quite the inverse. Targets are being set, great, and I'm very happy about this, and I'm sure most of you are as well. Targets are being set and industry has to follow. But the thing is not about certain targets that are problematic when we're looking to roll out e-mobility. It's certain conditions coming with it, and this is where the over-regulation comes. And one point, and that's very important, is the card payment obligation. And this is something that's been in a pain for many of you. And we are at the moment trying to figure out exactly above how many kilowatts, below how many kilowatts on the 10T network, which means the main corridors established by the European Union, so to say, where they are seeing main traffic happening cross-border, the core and comprehensive. And so an element that you have to keep in mind here is that one of the main jobs is to transfer the knowledge of the technology to create a realistic perception at the governance level. And that's one of my jobs, essentially, maybe the main job. Now, I don't know how familiar you are with lobbying. It can take many, many different facets. It can take many different approaches, many different ways, let's say. Some more with integrity, some less with integrity. I'm not talking about any specific companies, but you can imagine certain case studies yourself. But what I would like to talk with you is about a different form of lobbying. It's in the Sustainable Transport Forum. And the Sustainable Transport Forum, as a main body, is a kind of plenary, which is a bird's eye view of how e-mobility should roll out across the EU and advise the European Commission, which is the only institution that can essentially, not the only one, but in essence, as a general rule, the only one that can initiate legislation. It's the Parliament and the Council that discuss it and agree on it. And within this Sustainable Transport Forum, there are specific subgroups, which also Thomas touched upon before. The moment there are 3. They will be slightly transformed in the future, but there are 3. And the first one is what I would say is one of the major ones, and it concerns governance and standards, especially in communication, so all elements of communication in the whole e-mobility ecosystem. The second one is on data, and the third one is about facilitating the rollout of infrastructure per se. Now, the link between the STF and AFERE is a very, let's say, strong or strict one, simply because the work done in the STF subgroups is based on AFERE. So the work has started several years ago. There was a mandate given to start several years ago to focus on preferred standards in the communication and also preferred relevant instruments such as a PKI just to facilitate functions such as plug and charge. Now, what we should all keep in mind is that the Commission is here looking to focus on specific standards and protocols, which means, for example, if we're looking at the preferred communication standard between vehicle and charging point, it's the ISO 15118-2-20. That's a separate conversation I'll go into in a little bit. As I mentioned as well, you have PKI mapping. Other things that we're looking at right now, and this is more the activity 2. The activity 1 was the preferred protocols. Right now we're looking at how PKIs would be interoperable. One of the things that is currently being discussed is the creation of a certificate trust list, for example. Now the question is, how is that governed? How do root CAs fit in there? And so on and so forth. So these are things that are being more and more defined and established under the European institutions. Some would say that is over-regulations, others would say that is, let's say, certainty for the market. But again, it's a philosophical but also practical perspective. I'm very open and happy to discuss with you. What we're also essentially looking is at a transition period, because the certificate trust list does not exist overnight. Who governs it? Are we looking at an European institution governing it? I'm being warned. I'm a lobbyist. Sorry, I love hearing my own voice. So are we looking at the Commission governing it? Are we looking at a joint approach from the Commission and industry? But just to leave you probably with one note, that there's several different debates, and here the main debate is not only about what the result will be, but what is the transition. This is why the difference as well I'm making between -2 and -20. Because with -2, there's a lot of investment already being put in for some in industry. And for -20, I mean, it's published already. It was published this year. And in essence, we are seeing a market uptake, and we're hoping for a market uptake this year. But then the main discussions come, what direction, what timeline will be looked at. And this is something that we're doing in Caron, of course, and looking to see how we converge the timelines. But I know there's a preference for one than the other for others, and others are seeing that there needs to be several years. The whole point of my presentation today is essentially to tell you there is certainty coming to the market. That's the good news, that there is attention paid to it, but we do need to focus on having a different approach from the governance level. So on that note, I'll leave the floor up to questions. So thank you.
Thank you very much. One question by Mark Moulton, and then we'll head for the last presentation.
Hi, again from Switch.
Hi,
I understand that on a European level, they are more eager to support IEC standards and maybe ISO standards, but not so much the OCPP as a de facto standard. What's your view on pushing for OCPP and letting the IEC 63110 maybe not advance? What's your view on that?
My view on that is, well, okay, it's difficult when you have more than 300 members in an organization. You're trying to find a specific approach. But you also know that we are in Caron looking at creating parameters for OPNC, for example. So there is an essence of philosophy behind it. We're talking to the Commission, which in essence, and you're absolutely right, Mark, you know this well, is that they are looking at having standards being established under ISO, IEC, DIN, so on and so forth. And as some of you know, and Core, for example, from Charge Pump, we've had this discussion quite a few times, is that what happens is it takes too long. Wrong interests are vested. There is, let's say, the approach of slowing down processes and procedures because of the nature of the governance behind IEC, ISO, and so on and so forth. My view is that if the European Commission wants to really move ahead as fast as it wants and prescribes, then it needs to show that flexibility. And I'm in constant discussion with the Commission to say, hang on a second, guys. I mean, nice and good, but have a look at these open source standards, so to say, if I may put them like that, and see how you can adapt them over time to become an IEC and ISO, because they are going to be adapted. But get the ball rolling. That's the whole point. And at the moment, this is what we should be focusing on. I mean, let's not forget so many vested interests, so many financial interests involved, so much hope and so much aspiration. I mean, if we had a map right now, fine. And if we go further east in Europe, not as densely populated in terms of infrastructure as in the West. But these are more the bigger challenges to create that consumer confidence. And if we need to take that step, I think that's absolutely important.
Thank you very much. Time for the last presentation. You mentioned keep the ball rolling. Please be seated for the panel. It's an honor because I think we have on stage now the gentleman who rolls the ball. Frank, ELAT colleague, responsible for a lot of standard and protocol development. What are the technical challenges you are going to overcome the coming months and years to keep the ball rolling?
Yeah, well, there are plenty of technical challenges. I definitely not do it on my own, but I usually when the events I chair task groups and technical working groups, things like that to get our members to come up with solutions. And I know it's at the end of the day and the bar is almost ready, so I will keep it short. I only have 3 or 4 slides. But I want to dive into one new topic that is maybe the next step from vehicle to X, from vehicle to grid. That is how you treat an electric vehicle as a distributed energy source. Let me see. It works, yeah. Because this is more a bit like a follow-up of the keynote from this morning. If you start to do vehicle to grid, then basically the EVs become power generating modules or distributed energy resources for utility. And the actual vehicle to grid part within OCPP is already fairly clear. We have been working on that for 3 years by now. And we have all worked that out in the draft that we are preparing for OCPP 2.1. And basically a whole set of use cases and commands like extensions to the set charging profile where you can set points and discharging limits and things like that. That's, I think, the easy part. But now we get into the part where a utility might want to control the vehicle because utility wants to control the inverter of a distributed energy resource. And it has protocols for that, like IEEE 2030.5 or IEC 61850, to talk to the inverter. But how is the utility going to talk to the charging station if the charging station does not have an interface for it? Or to the vehicle if the vehicle does not have an interface for it? And that's where we are trying to come up with a solution with OCPP. Because there we say, what if we add functionality for this DER control, distributed energy resource control, to OCPP? So you get the picture like you see here, where the yellow line is simply the energy flow going back to the grid. And there we see that the utility then, move a little bit this way, utility wants to send, for example, a frequency watt curve to the inverter, or a fault right-through curve to the inverter. But how does it do that? Well, we say, what if we treat the charging station operator as an aggregator? Because we think it's highly unlikely that the utility is going to control independently tens of thousands of different charging stations. So we'll probably do that via the charging station operator. So the charging station operator communicates using IEEE 2030.5 or IEC 61850 with the utility. So the utility provides the DER settings that are required for a certain charging location, or maybe for an entire region, depends on the level of aggregation that this operator offers. And then this charging station operator can use OCPP to send these settings to the charging station. And here you see a very simplified representation of the situation, because it's a bit more complex than that, but you have something like a set DER control command, where you say, okay, I have a default setting for a frequency watt curve and then the curve data, and then that information is transferred to the charging station. So that way you can control or modify the net codes in the grid codes in the charging station. Now, then we have two different situations where you have DC charging and AC charging. In case of DC charging, the inverter is in the station, so it's easy to control. But in case of AC charging, the inverter is in the vehicle. So how do you control that? Well, we also see a possibility, namely the utility via the operator can still set these controls on the charging station. And if it's DC charging, then these settings are applied directly to the inverter in the station. But if it's AC charging, then you make the charging station makes the EV inverter follow that grid code. So, for example, if you have 15.11.8-20, you have a lot of fine-grained control over the inverter. And so in the AC charge loop command, you can vary the power or the voltage or the reactive power very rapidly. So that way, the charging station can make sure that if it has, for example, a frequency watt curve installed, it can make sure that the inverter in the vehicle behaves according to that curve. So it is still a proposal that we are working on and that we are investigating with our members and other parties to get this completely right. But we believe that this will definitely be a way how you can make sure that the grid codes are controlled, even when you do AC charging, without the need for a dedicated IEEE 2030.5 interface to the vehicle, for example. And I think this would make adoption of V2X a lot easier. And with this, I would like to round up my talk, and I will be open to any questions on the topic. Thank you.
Thank you very much, Frank. We're almost at the close, at the end of the session.
Yeah.
I see one question by Achim, but he made up his quotum of questions. Someone different today? No, then brief.
Yeah, we have a question.
Oh, yes.
Yeah.
A new member in the audience.
So, hello, I'm Bart Korteweg from Equins. Obviously very interested in ways that we can work towards having vehicle-to-grid functionality on AC charging stations. It might be because it's the end of the day, but I kind of missed how your proposal is going to enable you to circumvent the grid regulations, the national grid code regulations that are applicable to the unit that's actually producing, delivering power back to the grid.
Well, we're not trying to circumvent the national grid regulations. We're more in the business of trying to enable them. Yeah, of course, if you have a DC charger, then that is static. So it will probably be delivered and be compliant to the national grid code. But if you have a foreign EV, its inverter might not be compliant to your local grid code. So that's when you want to make sure that this inverter does behave according to the local grid code. And that means that the charging station needs to get the functionality to control the inverter in such a way that it does not violate the local grid code. And you could do it, have that just statically, where you say, okay, this charger just only enforces this grid code. But we expect that in the future there will also be a need for a utility to be more dynamic in that. You do not just have one static grid code, this is it. But depending on the conditions of the grid, you might want to have some variation. So that you want to maybe sharpen up the frequency watt curve a bit, or loosen up the reactive power curve, things like that, depending on how stable or unstable the grid is at the moment. And that is what we're hoping to achieve with providing the capability of transferring that information via OSPP.
Thank you very much. And also keep in mind, we live in Europe, an open economy, and the vehicle standing here today in the Netherlands might be a second-hand vehicle at Antonio's grid in Italy, and afterward a third-hand vehicle in Spain. And you never know where the vehicle is going. So bi-directional charging on your holiday, so you're fed up with 1,000 kilometers travel all the way down to France, you probably won't discharge your vehicle. You want to start on your holiday. But keep in mind, we also have to be prepared for the second-hand market. And Frank is also envisioning a solution for enabling that.
Yeah.
Yasmine.
I think it's time to conclude. I'd like to thank you. But before saying goodbye, and I mean the bar is open, few questions probably, and I will make it short. We have seen the different positions in the, I would say, value chain, from the transmission system operator, distribution system operator, somehow that you're representing, and then the communication between car and the charging station. So all of them are so important to make it work. And sometimes when you're at the utility side, you see cars, battery on wheels, and sometimes when you're on the OEM side, you see the whole world of energy as utility. You know, the big thing, no one knows it. But we see that you have transmission system operators with some topics, you have distribution system operators with different challenges, and it was good to have you all around the table. And thank you for your valuable presentations. Without taking your time, what would be, in your opinion, and I will start by you because you have finished this, what is one topic or that you want to put emphasis on to have vehicle-to-grid scalable and to make it a reality, more than pilot projects and slides and everything? What would be this topic?
Well, personally, because that's also why I was talking about it, I think it's important to get this whole thing with netcodes and V2X right. And also, personally, I think there's more future in AC V2X than DC V2X, but that's my personal opinion, just because AC vehicles are connected longer to a grid, so you have more opportunity to use them for that purpose. So that's one thing that I think that needs to be solved. And the whole other thing is more the financial part and the tax rules around it. How can you make this worth your while to actually do it? Because I have not really seen a good solution for that. But that's not my business. I'm more into the technology, so that's why I stick to that.
Thank you very much. And from a tax perspective, we have seen that there is evolution. There is no double taxation normally, and yeah, there is also something we didn't talk about, but we didn't have time. There's a lot to say on the new market design and everything that this new market, electricity market design will provide. But Glenn, what will be your
Well, I'll continue with my personal views and kind of highlight the point of certainty, and maybe one angle of that certainty that I didn't emphasize on earlier is, for example, when we're looking at the establishment of interoperability systems, so certificate trust lists, and we have this transition period happening right now, for all of those that are going to need the root CAs, for all of those that are going to need to know what technology to use. In a transition period, you need to look at the end result, but with a certain flexibility because of technological development, of course. But the building blocks that get you to that, so to say, end result, you need to already start looking at. And I think this is something that we should all really focus on. And at the end of the day, I mean, certainty is also a commonality in being able to move towards the same direction. But voila, that's mine.
Thank you.
Yes, well, you mentioned there's a market evolution going on, and that's true. Allow me to say that I think whatever drives the market evolution at the end is money, really, because whatever provides flexibility to the grid is whatever is cheaper, because we need to provide a service that is cheaper for the end users that are paying the bills. And my opinion on that's at the end, yeah, the main thing. And my opinion is that my suggestion, I would say, is that I feel like we really need to focus on softwares at the moment, so communication protocols. I feel like hardwares, they're well known, there are inverters, there are batteries. I mean, there's nothing special really, but for communication protocols, I really think we need to make one, maximum two standards and make interoperability not an issue anymore. Just think about aggregators. If they need to integrate 2, 3, 4, 5 different communication protocols, then it gets too expensive for them and they won't aggregate distributed energy resources. So that's my opinion on it.
Very good point.
Collaboration and inclusion, flexibility, so that we move in the same direction.
Collaboration, that's the conclusion, I think. A very good one. Baerte, you want to conclude?
Yeah, couldn't agree more. This panel isn't a conclusion, it's a start. Well, not the start. We're on our way in mutual projects, flow together with partners as Caron, developing day by day. The coming days, there's also a plug fest here. You showed it as a look in future for new plug fest topics on 2.1. But you're absolutely right. We have to do this together. Collaboration, harmonization, standardization, and maybe in the end, regulation. But that's a good thing. Ben is all the way in the corner. There's a senator in California who wants to regulate bidirectional charging. So let's provide him by real practical solution that it can be done. Thank you very much. Please have a drink and share your thoughts and give us some input for future events. Thank you very much.